Oh, hey, and did you want to try another light so we have extra good lighting?
Yeah, that's a good light.
What it normally does is it hooks on over your thing, but it's kind of made to do stuff like this. If that, no, that's gonna adjust it. What if
No,
I?
that's good. I thought it'll counterbalance it.
Yeah,
Here,
it goes right over the lens, but yeah, however you like it there.
because the lens is pulling the camera the other
Cool.
way. That's perfect. A soft light. Oh, I gotta plug this in. That's right. This will battery will drain.
So we've been talking about the potential of intelligent energy.
Yeah, should I turn the AC off?
We can turn it up for now. I'll turn it back on if it gets like too cold. Do I just rotate this thing?
Yeah, straight up.
Straight up?
Let me turn the fan off. Let me turn it on if it gets too hot.
Yeah.
You can just turn it on at any time.
Cool.
If you need it on. Okay, so the stream is live at 1 minute and 24 seconds now.
What is this thing called?
What?
This whole device, which goes from this motor to this
What do you
device.
want to call it?
Is it a power generator?
This is a blender motor, and this
Okay.
is a dishwasher water pump motor.
And you
And
modified this, correct?
yeah, I put this was the original rotor that was inside, and I put the rotor that was inside this Castle Creations 100,000 RPM.
100,000?
Yeah, it's right there. You can see it right there.
Oh, that's beautiful.
100,000 RPM. Let's see if it shows here. 100,000 RPM motor.
And the original rotor, you can see that it's magnetic here. It's sticking to this iron, ferrous metal here. It's not very powerful magnetically. What's the difference between this rotor and the rotor you installed there?
The rotor that's in there now is so strong. It's very, very strong. It has, I think they call it neodymium magnets.
Oh my gosh, look what I'm doing. Do you see this light? Does the camera see this?
Yeah.
Okay, I'm just having fun.
And that's not even a very strong.
It's just too much fun.
That's
All right.
not even a very strong magnet.
What does this thing do?
Well, we're noticing that when you charge a battery with it, we're just going through a full wave bridge rectifier, which are available on Amazon. I don't remember the specifications of it. I think it might have been like a 250 volt, at least a 40 amp. But, I just tried to get something that was going to be, this was for other experiments. It was being used for other higher powered experiments.
Mm-hmm. So you've used it before, you know that it works.
Yeah.
And what you do is you put high voltage into it, and okay, what does a rectifier do?
It has diodes in it, and this is all very new to me, so I'm going to say it this way. I think they're called diodes. But that sounds right to me, diodes. And the diodes keep energy flowing in one direction, and from what I understand, they convert like an AC signal, which is what this is generating, if I understand correctly, into DC, which can be used to charge the battery.
And so in our camera, we can see we've got all this. So we've got 12-volt battery, we've got rectifier. This motor is plugged into a power supply. It's not in camera view, but that's plugged into 120 volt in the wall, and it's got an adjustable potentiometer on it. So it reads what? Voltage 120, amperage 15A is what it says?
Yeah.
So could that possibly mean that is capable of 15 amps maximum?
Yes.
Minimum, something like that?
I think so.
Okay.
Without overheating.
And you've used this motor to couple to this as we could call a generator or an alternator through a coupler, which is kind of like a boat coupler. I feel like that's what they use on our remote control boats and stuff sometimes.
I would just call this a charger, I guess, for now.
Okay, charger.
But it's can be also referred to as like a resonance force, resonance flow generator. It generates pressure.
Mm-hmm. And we've observed running this at 120 volts and maximum of 15 amps. We've observed this to produce what sort of output?
We had it earlier running at, what was the voltage on low? It was like
300 something?
Yeah, it was over 300 volts,
Mm-hmm.
and then on high it was almost 500 volts, just under 500 volts.
Mm-hmm.
What was interesting is we had it going into the full wave bridge rectifier, and then it on the output coming out, the black and the red, it was charging this battery which was at 6 volts. This is just an old lead acid battery that is has been sitting for a long time. It's been used a lot in different experiments where it's just been drawing the power out of it, and not necessarily kept charged properly.
Mm-hmm.
So the voltage on it was, I think it was at 6 volts.
Mm-hmm.
And we did a test where we saw what would happen if we run this into the charger, to the battery, and the voltage went up right away. It went right to the what was our reading?
Okay, well, the lead acid battery started around 6 volts. We turned this on, and I believe it went to 14.3 or 14.5, and then it was kind of fluctuating, and I believe that it sort of settled down about 13 and a half volts. And I know this being a 12 volt battery, despite it being at 6 volts, 12 volt batteries, if you're concerned with your charging system on your Mitsubishi or your Toyota, you hook up your voltage meter and you expect it to be like 13 or 14 volts. That's my experience with functioning cars and car batteries. If you go to if your Toyota has 11.5 volts, you've got pretty much an incorrectly working system, right?
Yes.
But charging out of your alternator, I believe, 13, 14 volts seems correct. So we want to talk about intelligent charging, I think, today, because we should show the viewers at home what numbers we're getting, but I think we should show them what this outputs, which I think is going to be depending on that potentiometer, it's going to be 300 or 400 volts. We need to show the viewers at home that this battery is reading 6 volts, and that's where it is. It's a 12 volt battery, so it's low. And then I think we need to connect this battery to your energy production device and see where it's charging. What does the voltage show when it's charging? Maybe let the viewers at home think, how did it go from this voltage to this voltage?
Yeah, that's a good thought.
Want to show them the voltage on this running by itself at lowest setting?
Sure. So I unplugged everything. Yeah,
it's unplugged. Why don't I hold this so that viewers see it really good? If you want to, yeah, there we are. That's really nice. Is this the one you're going to use?
Yeah, but I just realized. Let me connect this back up here.
Sure.
Wait, how are we going to do this?
I think we just need to touch.
I could just touch them on there directly
to it.
Okay.
Once it's on, and then as long as you make sure when you're using the multimeter, what setting do we put it on?
You have to make sure that you look at the screen, because the light could be causing a glare where you can't read it. So make sure you look at this and not that.
Gotcha.
Okay, make sure always look at this screen.
Sure.
So we can turn this on.
Okay.
Okay, and then.
So right now we're reading.
So you can see it's not
0, and we're on millivolts, and so the MV there, and I'm gonna try to get it so the camera sees.
It just means there's nothing.
MV means it's lower than a volt, so it means it's not a significant read.
But it's all zeros, so there's nothing.
It's all zeros.
It's showing 0. So what we're gonna do is go ahead and turn it on. Ready?
Yeah, let's turn it on.
It's on low, the lowest setting. Okay. Wait a second, is the meter working? It may not be working again. It's not working.
No, we just got 386. Something just worked. 300 and something. Now we're at.
It's not working.
Now not working again.
Let me try the other meter.
Okay.
It could be the battery dead.
Yeah, yeah.
Okay, let's try this one.
I think we may have used that other meter before. Repeatability. And that's the correct setting on the multimeter?
Yeah, it's on volts.
Okay. 300. I just saw 365. I'm trying to get this so the camera is good. Okay. Yeah, we're at 365 volts, 367 volts. You want to show them with the potentiometer cranked up and see where it goes?
Yeah. Is it working? Is it showing?
I'm not sure. Is that saying it's 478 volts period without points anything? So we're at 478.
Okay. All right, so that's a lot of voltage.
That is a lot of voltage. And we were talking about what is amperage, and you had what is it you described to me you thought amperage was?
Well, the way that I've, like in studying amperage and resistance, one way that it's been described is that amps are after the fact. Amps come after, when there's a load. I don't know if we would say it comes from the load, but it's, I guess, amps are maybe dependent on the load.
So without a load, we can't measure the amps. The load is what proves us what the amps are, kind of, we might say.
I don't know.
Do you want to prove, or do you want to just observe what the battery voltage is before we try connecting it?
Yeah, so let's do that. So let's see. Let's hook this meter up now and hope I don't burn it out. I think the other one just has a low battery.
Okay.
Okay, so hello everyone. Welcome to True Zero Emissions, where the goal, right? The goal is to learn. And we're trying to learn.
We are trying to
We're
learn.
here to learn. And we're sharing ourselves learning. So, welcome to our journal.
Exactly.
Okay, so we showed the voltage of this already.
478 volts.
Yeah. Now what's really interesting is when we connect it to the battery, and this has been referred to as like an intelligent energy. Intelligent energy
Generator.
But it doesn't really.
Energy
Is it
pusher?
generating? I don't know that. I mean, energy's everywhere, so this isn't generating energy.
Maybe it's lassoing. Maybe it's more like it's gathering, or enabling.
It's been
energy enabler.
It's been referred to as a pump sometimes.
Okay.
As an energy pump that pumps water. Right. So water is like the body of energy that in the pump just moves it from one place to another. How does that sound?
I like it.
That's
I know,
way it's been
I know.
set
I would
up.
think the traditional science says the thing that we are moving is electrons. Are you for or at all against or neutral to the thing we're moving as electrons?
I'm for learning. I'm against not learning.
Okay.
I'm still learning what an electron is. I'm sorry.
Me too. I've never seen one.
I
I think that we talk about fables a lot, don't we? Like we talk in metaphor.
Yeah.
We'll talk about something, and it makes me think. I don't want anyone to get insulted with me mentioning religion or the Bible, but I think of the Bible as this very useful book that teaches people stories. It teaches them lessons through fables, and a fable is a story with a message, with a moral. And it almost makes me think that traditional electronics is a bunch of fables because they make you think about it a certain way. For instance, I live on this ground, for there is no sky. For I only live on the ground. The sky doesn't exist. I think we all know the sky exists.
Right.
So I think Joseph and I are trying to discover where the ground meets the sky, perhaps.
I got an idea. I just want to take a peek, and you can see here, I'm just taking a peek to see if this stream can be seen, because I know the last live stream we did,
Okay.
the last hour, wasn't visible. It was
Sure.
just audio. I'm grateful the audio's there, but we want to know that we can see as well.
Okay.
So let me just see if we can. Now let's see my hands here. Let's see, it's showing. Is it showing my hand? Yep,
Oh,
there
there
it
we
is.
go.
Yeah, there's
All
my
right,
hand.
all
So
right.
looks
It's
like
happening.
everything's good there. Okay, so we can periodically check that.
Mhm.
My hand's still there. Okay, we can periodically look at that to make sure it's still working. That's a good idea, wasn't it? I like what you said too about that. The way you presented that. Very interesting, Cameron.
Because I think a lot of people, we want to be science-based, we want to be black
Yeah.
or white, and rules, laws.
Yeah.
But if we really are learning through metaphors and fables, we may be cutting ourselves off to
Right.
more information that's not within our fable that we learned.
Yes.
So I think we're trying to figure out what's a fable and what's not.
Absolutely. Yeah, yeah.
Kind of.
So what would that look like in terms of if something is a fable and something's not? Tell me about the not. How do we know when something's not a fable? For example, let me just ask you this, and if you want to interrupt me, please do.
Sure.
When we see that this 470, what was it, 475 volts? When we see that 475 volts instantly adjusts to this battery, which is a 12-volt battery, which had 6 volts in it, before we were streaming this, you and I had done this, and we can do it again here with everyone seeing. This battery that had 6 volts in it, it went right up to, what was it, 13 or 14 volts, which is what a fully charged lead acid battery would go to. We didn't run it very long, but we were just noticing how the voltage, it didn't overcharge in a way. The voltage wasn't putting 400.
It didn't say 18 or 48
Yeah.
volts. It said 13 to 14 volts consistently.
And I also noticed that with the scooter battery when I did the test where I was charging this, I was using this system to charge it's called a 36 volt nominal, but when it's full, a lithium scooter battery, when it's fully charged, it's at 42 volts.
Mm-hmm.
This brought a lithium battery, scooter battery that was at 36 volts, so it had room to be charged more. It was putting in 41.2 approximately, which is amazing.
Which is what the charger puts out pretty much, exactly.
And then
right.
when I monitored the battery charge, it was slowly coming up. Very slowly, but it was coming up. And one of the things I want to do is these little bulbs here this is what's called a neon bulb. And Gerard Morin does experiments with these, and he referred to these as an improved version, and I'm not quoting him, I'm just paraphrasing, which is an approximation of what he said. This is an improved spark gap, because a spark gap magnifies energy and amplifies it, and also increases the frequency dramatically, which I'm wondering if that comes partly from the idea of what Thomas Bearden talks about when he says that all particles, all subatomic particles, which are the building blocks, if I understand it correctly, of atoms, which is the building blocks of everything that we are and walk through and see.
According to our science fables.
Exactly. And I'm totally open to learning something new about that, always. But that that particles are all charged, because particles are charges, from what I understand. and they're charged, and those charges are maintained at 10 to the 120th. So I might be off by one or two zeros or a couple zeros, but 10 to the 120th is how you say it. Now what I understand that to be is it's basically 10 with 120 zeros behind it. Or
Yes.
maybe, does that sound...
10 to the 6th is 1 million, so, and 1 million has 6 zeros on it.
So it
10
is.
to the 6 is a 1 with 6 zeros, so,
Okay.
like you said, is correct. Yeah.
Okay, so I said it correctly?
Uh-huh.
Thank you, Cameron. So 10 to the 120th is a very big number. You can look it up on Google. I did before. I just don't remember how to say it. There's lots of big numbers. But our house electricity is pulsing. I'm calling it a pulse, but it's do we say pulsing, I guess?
Hertz.
Pulsing?
Some people
Yeah,
call it
cycle.
hertz.
A cycle per
Cycles,
second.
Frequency, hertz, right?
60 cycles per second. But particles are being pulsed or charged. Their charges are being maintained at 10 to the 120th. So 10 with 120 zeros, very big number. That's very, very fast. So when we have a spark gap, we're magnifying. This is how I understand Gerard Morin to be explaining. This is my interpretation of what he's saying. We're magnifying and amplifying the energy by going through a spark gap. And you can go up to 3 spark gaps. So we're going to try putting a couple of these in series and see what happens. And see if it changes the way that a battery charges. I had one of these connected to this system when I was testing last night, and it worked, but it burned the bulb out, and that's so I'm not sure how or why. My meter also stopped working. It didn't like. I don't know if the battery just went dead or if it damaged it, but I was curious what the voltage was going to read when I had this connected to this. This is This is a 200 and I think it's a 220 volt neon bulb, and it's red, the color. I think Gerard Morin was using 120 volt neon bulbs, 120 volt. So these were only a few dollars on Amazon. They make a lot of different ones, and well, let's do some more testing. What do we want to do? Oh, we didn't charge this yet. Let's show everyone what
I
happened.
think we should show them what the voltage is in this lead acid, probably.
Okay, well, let's go ahead and see what we have. Or here, would you like the honors of turning that on?
Turn it to which
Let's look
position?
first. Okay, let's look. VAC is volts AC.
Volts AC.
Second one up.
Oh.
Yeah.
Volts AC.
Because we know that's what's coming out.
And right now, what's connected to this?
Oh, well, let's look at all that. Let's set this
Okay.
down. That's a good thing to ask. Okay, so let's see how much of the wires are in the camera here. So let's see. So we have our meter connected to the battery. Okay, so these wires are going to the battery here. And
Through the...
the full wave rectifier...
Not through the rectifier. So we've got this one going direct to the battery, this one going direct to
Look
the
at
battery,
the-
and
look-
a rectifier is not.
You have to look here when you're talking because your hand was
Gotcha.
out all down here.
I see.
This is the
Okay.
frame over here.
Gotcha.
Yeah, right
Gotcha.
here. Okay.
So
I can lean this down.
the wires, even though we do have we have a rectifier connected, that's not what's connected to the wires on the poles of our multimeter.
Yeah, so what we have is out of the dishwasher water pump motor right here, which we put a Castle Creations neodymium magnet, because Gerard once said if you put a remote control car motor, which this thing has 100,000 RPM ability, if you put the magnet in here, inside here, he said you would have a lot of power, and that was correct. It was a lot more power.
Because you had a noticeable jump from your first
Yeah,
rotor.
this is what came in it.
You had, do you remember how many volts it was?
I think
initially?
it was over 100 volts more with this one. Over 100 volts more with this one here.
And we know that neodymium magnets have a lot more attraction than your standard magnet, so we have to think that the magnet itself is responsible for that change in voltage. is what my brain says.
Mm-hmm. That's what it
Okay.
seems. That's what seems to me.
Okay.
So these two wires, the white ones coming out, are going into the full wave bridge rectifier, and and then coming out, we have connected to the battery. Okay. So let's just see what this does. It's very interesting. So let's go ahead and disconnect. So we already showed the voltage of this earlier, right? Should we show it again? Without
I think we're good with that. I
Okay,
want to show them the 6 volts, so they know, so they don't
Oh
have
yeah.
to trust us.
So how can we? Oh, so let me go to DC. Oh, I put it on AC. We're not reading this. We're reading battery. That's DC. You were right.
Okay.
You were right the first time, Cameron.
Fair enough. Is
My
that
apologies for that.
no problem? Is that reading 6.32 volts by coming through these 2 wires right now?
Yes, that's going right to the battery.
Okay, so this lead acid battery is 6.32 volts, and we know the lead acid battery wants to be 12 volts.
Yeah, and this battery's been sitting
Okay.
like this for a long time, like months.
Okay.
Very low.
If we leave this voltmeter on right now and we turn this machine on, do you think that's safe?
Well, I never know when the meter's going to get burned out with this kind of experiments, but I'm willing to take a chance.
We'll take a chance for a moment. Want to just flash it for a moment and we'll kind of observe the voltage run up and down, maybe?
Yeah, and try really
Okay.
hard to not let the glare get in the
Yeah,
thing.
I am.
'Cause then you
I've
can't
got
see
glare
anything.
management going.
Glare management.
So we're at 6.32 volts currently, and turning on to just bump the low setting.
Yeah, that's better. See how you can see the
Okay.
dot?
Got it.
We
got
prefer
it.
to see the dot so we
Okay.
know what the volt what it's, you know.
Cool.
Okay, ready?
Yep.
Okay. Okay, so we're on low. We're on the lowest. Oh, this isn't showing anymore. Let me bring it over here.
Oh yeah, there you go. Now we've got both. Perfect.
Yeah. So this is on the lowest setting. See, that's the highest, and that's the lowest. And to the left would be using this, and to the right would be full power, bypassing this here.
Oh, okay.
So we're going to go to the left. That's a little fuse there. So this is a different system than I was originally using. Okay, here we go. This is all from Amazon. Thank you, Amazon. Very grateful.
You're
for-
welcome.
I buy 99% of everything on Amazon now.
Oh,
So special thanks to those who introduced me to Amazon, which is my friends.
Oh.
Okay, so ready?
Yes.
All right, so we're on the lowest setting. And earlier when we ran this on low, it was at
478 volts.
no, that was high.
Oh,
low
high
was
at 478 and 300.
Low was 3 something.
Yeah, 300.
Okay, and that's earlier in the video. Just go
Uh-huh.
back and look at that. Okay, let's go ahead and see what this does now. So we're at this lead acid battery, which is just, you know, hasn't been charged in a really long time. Let's see what it does.
14 volts.
That's amazing.
It goes directly to what these usually are charged at.
Okay, so I'm going to turn it off just so we can talk.
Mhm.
That's really amazing that it's as if, I don't know how to say this, and please improve what I'm saying if you think of any way to do that. But this motor, which I'm calling it that because that's what it's a motor from a dishwasher water pump.
Mm-hmm.
Okay, I purchased it on Amazon. I think it wasn't that much. It was inexpensive. And it does. You don't have to put this stronger neodymium, inside. It does. You can use this one too, and I
Mhm.
think it would do the same thing
Mm-hmm.
from what I've seen in studying this. But I just wanted to use. Gerard Morin said, if you put one of these in there, it'll really make a lot of power. So I
Mhm.
thought, why not?
Mm-hmm.
Why not try that? So I found a broken, this was broken. See, this is where it connects to the RC car, and this had broke off,
Mhm.
but the rotor was still good. Just the case broke.
Perfect.
So it was perfect for this experiment.
Perfect recycling.
Yeah, we were recycling, true zero emissions.
So what I've noticed here, we're at 7 point. It's
It went
slowly
up.
dropping.
It's
yeah,
dropping.
it did go. I mean, it went. It was in the 6s. It
Yeah.
went up a bit. Do you want to try an experiment and run it for 60 seconds and say where is it after 60 seconds?
Why don't we let it run for a couple of minutes?
Yeah, let's do it. Do you want to do a timer or just do it?
We could do a timer. Let's
Okay.
see.
It is slowly dropping. It's dropping like let me see. The first position after the decimal is hundreds, thousands. It's dropping a thousandth every 10 seconds or something. But
But look at it staying at 7.28 pretty well.
yeah, I mean it was at like 7.3 something a minute ago, but still that's not dropping super fast. I'm just curious if it will, like, if we run it for 60 seconds, does it get to 8 volts?
Let's see.
And if it does, I mean, that means that your charging system is a charger. If I just called,
Oh.
I don't want to know if we've had trouble naming what this is called. We're not sure what to call it. But
Yeah, and we want
our
to
device, Joseph's device. I didn't make the device.
No,
It's
no, it's
Joseph's.
not Joseph's device.
Oh.
We call it
Well,
Gerard Morin's
Okay,
device.
Gerard's
And Gerard
device.
Morin is a student. I would say I'm going to refer to him as a student of Tesla, of Nikola Tesla.
Okay.
So he studied and practiced Nikola Tesla's work. So,
How many seconds do you want to do our charge for?
let's do it for a few minutes. What do you think?
2 minutes straight?
Let's
3
do like
minutes
5.
straight?
I don't know.
Okay.
At
5
least
minutes
3.
straight.
Yeah.
Okay, then I'm going to set this down
Sure.
so my hand doesn't go crazy.
Yeah,
Or
yeah.
maybe we set it on here. Is that good? Is it up higher? Is that a good idea or not a
Let's
good
see
idea?
if it reads there. It might read
Okay.
right there. What do you think?
Yeah, I think that's good. I think it's
I
decent.
mean, let me put something underneath it to make it easier for people to see.
Let's see. What is a something?
Let's see. I could use maybe this box. Let's see if this box can be used. Just tilt it sideways like this.
Oh, that's looking real good. You don't think that'll fall or anything with the
I
motion
don't
of
think
it?
so,
Okay.
but okay, let's go ahead and run it.
Approved. And we started about 7.28 or
I'm
7.
gonna try turning it up.
Yeah, why not?
Let's
Turn
see
it
what
up.
the voltage does.
Sure.
Look at that. The voltage stays the same.
Yeah, it did not go up. It did not go up.
That's amazing.
I mean, I feel like it kind of went down,
Yeah.
which I'm not sure how to interpret that, really.
Well, maybe those could be different tests. Maybe I should leave it low.
Well, I'm picturing a condition right now. Say you did it for 5 minutes on low setting, determine the voltage increase, and then later on did it for 5 minutes at the high setting and determine the voltage increase.
That's
Maybe
a good idea.
One is exponentially more, or
Yeah.
maybe they're exactly the same. I don't know. But I think one thing we could say is your 120 volt power going to this motor is more when you crank that high. I mean, I think we would probably agree that you're drawing more current out of the wall when you crank this up and run this motor.
Yeah. I'm focused on how the battery's charging and what the energy's doing right now. You know what I mean? But you're right. That's part of it. But we know there's plenty of energy, right? We know that it's just how to move it, right? I think that's what we're looking at. But I don't think they can hear us right now talking.
Maybe not, yeah.
We can repeat this though when we're talking.
Cool.
This is important.
Yeah.
All this is.
Yeah.
You can sit down, Cameron. Save your energy.
Yeah, I'll take a look. I'll use the bathroom for a second.
Okay.
it's interesting. It's down to 11.6, and they probably can't hear us so much, but I wonder, at some point it's gotta stop going down because the battery's probably got, 7.5 or 8 volts in it now, and it's slowly dropping. But I wonder maybe this battery, when the battery gets up to 9.5 and this gets down to 9.5, maybe it stops and then that's the capacity left in it. But I have no idea.
Yeah, I don't know either. I'm going to see if it changes when I go up with this.
Yeah. Ooh, it goes up a little bit now. Now that it's lower. Well, no, now it's down again. Huh.
Look at it.
Do you have a prediction for what the voltage is going to say on this when we turn it off in the 5 minutes? What's your predicted? I'm going to cover this prediction. What do you think it is?
My prediction is that I'm going to learn something.
I predict we'll both learn something, and I predict the number is going to be 7.83. 8.2. So we significantly charged the battery in 5 minutes. Right?
That's really interesting. Yes. Yes. And again, somehow this dishwashing machine, water pump, drain pump, I think it is what it is. Even though the voltage of this, the output AC, is 300 and between 300 and 400 on low speed, and between just under 500 volts on high speed. When we connect it to this battery, which was at 6 volts, and it's usually 12 volts when it's fully charged, somehow this went right to, originally when we first started this, it went to around 14 volts, 13 or 14 volts. And then it came down a little bit over the course of a couple minutes. It came down to, what was the lowest voltage it went to that you recall?
I forget right now. I'm not sure.
I feel like it was 11 something. 11.
Yeah, maybe like 11.5, something like that.
Yeah, so it was coming down, which is interesting as well. But right now our battery voltage is at 7.8, so it did put some energy in the battery. Interesting. I mean, to me, what's most interesting is that somehow this won't overcharge this.
We had hundreds of volts.
Hundreds
and I
of
was
volts.
concerned. I think you were at least the first time concerned.
Yeah, I
and then
didn't know if it was
determined that it was safe. What if we took an 18650 battery, which it turns out 18650 is what, 18 inches in diameter and 65
18 centimeters, you mean?
millimeters
centimeters?
in it?
It's something small.
18 centimeters would be this.
Oh, yeah.
18
Millimeters.
millimeters is about 2 centimeters. So we're at like 18 millimeters here and 65 millimeters here. 18650. So these batteries are 4.2 volt fully charged. Is that correct?
Yes.
And this one, I don't remember if we checked it or not, but
This is down to 6. This is down to 6.5
okay.
now.
So so this battery probably is, past its best life cycle, just in general.
Yeah.
But with this battery, what do you think, if we connected it to charge with this, how many volts do you think it would be charging this battery at?
I don't know. We can try that. This battery, this is the one cell of all the cells that were totally, almost completely depleted of charge in terms of what the meter would read. I was able to charge all the cells that were depleted except this one. And this one, these have water damage. I mean, they were shorted out. I don't know, water damage. They were in water. A scooter that was submerged in water.
Yeah.
This is one that when I charged it was charging a little bit. It charged a little, but it was getting hot.
Okay.
Heats when charged. That's what's written on there. Heats when charged. That's what I wrote there.
Okay. You don't have a little infrared
Yeah.
temperature gauge? Oh, you do.
Yeah,
Awesome. Okay.
Yeah, it was getting pretty hot, so
Okay.
I didn't risk continuing to charge it when it was getting hot because there just was
Yeah.
no need to risk that. But I could just feel it. So we can try charging that, but we can also have some others that we can try. I think you brought this set over.
Yeah.
So we can
Whichever
see.
you think is safe, I would say.
Well, I'm curious
Whatever
what this will
seems
do.
safe.
I'm curious.
So we check the voltage of this first,
Yeah.
see what it is, and then run it on our system and see where it charges would be interesting. Because yeah, I believe that the trickle charger for it is going to be at 4.2 volts. The charger, I think that's the volts it puts out.
I'm just giving us something to grab onto here
Yeah.
with the meters. So, and by the way, when I was charging those, this is a different system that Gerard Morin uses. This is similar, if I understand correctly, to what a power plant uses, but they use very, very large ones, which is, that's just if I understand correctly. But this is what's called an outrunner. An outrunner. It has the magnets on the outside, so this turns, and the magnets are on the outside. They're inside the case, but they're on the outside of the rotor. So, and that's, see, so there's the rotor inside there with the coils. This is they use these for helicopters and helicopters and like remote control helicopters and remote control airplanes, like model ones, small ones. But this is considered a big motor for that. So I had this larger motor spinning the small motor, and the energy coming out of this, these are similar motors, these are both outrunner motors. This was being used to charge batteries. And that's how I charged all the lithium batteries, even the ones that were depleted. And then once I brought the energy up, I could plug the regular proper charger to it. The one that, I mean,
Yeah.
when I say proper, I just mean the one that that was made, the standard one, yeah. But this got the power back up to that area, to that.
Yeah. And the one you just showed us typically runs less voltage than this one. I think we were discussing.
Yeah, this is a
before.
lower voltage. This is, I think, the most voltage. It's around 40 volts.
40. Okay.
Yeah, around 40, 30 or 35, 40 volts when I'm spinning it, and that's just with using a 36 volt nominal lithium battery, which is 42 volts fully charged, as the power source to spin this motor, to spin this as a generator. So this, I think that controller, the Castle Creations Phoenix, it's a Phoenix 85, which is an old model. I think it can handle higher voltage. I just don't know what the maximum voltage is at the moment. And I had I just used what I had at the moment, which is that battery that I had. And that was able to bring these batteries up to charge again. And some of those batteries that were not working are being used on the Mercane Wide Wheel Pro as my extra batteries and working very well. That scooter has between an 80 and 100 mile range, depending on how you ride it.
Wow.
So if you go if you're doing like 17, 18 miles an hour, it'll easily go 100 miles.
Wow.
Because it has 4 full-size batteries on it. And those batteries, like I was saying, most of the batteries on it were batteries that were dead. And I brought them back with that.
You know, there was a guy who did something called Scoot Across America a few months ago. This guy Alex something, and he got himself about 10 scooters in a trailer, and he traveled from, I think it was like New Jersey to, I don't know, somewhere in the West Coast. And I asked him, I said, hey, are you gonna use any extra batteries on your scooters? Because he had some Wolf Warriors, he had a bunch of other scooters, and the Wolf Warrior maximum battery is like a 72 volt 28 amp hour battery is what was available when he purchased his. And so the guy, he encountered a lot of issues with his scooters, but I think the main issue is if he had your scooter, he wouldn't have had to stop as much. None of his scooters had long range.
Yeah.
Not one.
I mean, that's how I think we're thinking that way. Some people might not want extra batteries on their scooter. they might be uncomfortable with the extra wires or modifying their scooter, right? They could be
Yeah,
uncomfortable.
oh yeah, especially if they're not
Yeah.
willing to work on something, or even I
Or
know
if
I
it's not
personally,
familiar to them.
I'm willing to fail. I'm willing to have my parts destroyed so I can learn something. So not everyone's willing to lose their
I'm the
stuff
same.
in
Yeah,
learning.
I feel the exact same way
Hmm.
when I put all those extra batteries on the scooter. If the whole thing just disintegrated, I would say, "Oh, I learned something."
All data is good data,
Yeah,
even when you're I mean, fire isn't the best data, but
yeah, yeah.
you
We don't
know,
want to get hurt.
we
We
don't
don't
want
want to
to.
get hurt.
But I don't mind if a part gets damaged so
Yeah.
much.
And parts are you can change parts. And the most important thing to me is learning,
Hmm.
right?
Yeah,
It's to
sometimes
learn.
it takes burning a part out to learn, so
Yeah.
it's not the worst. Although, if you buy a brand new scooter for $2,000 and you start experimenting on the battery, maybe that's not the best thing to choose. Like, I think I would use something free to experiment on because there's no monetary loss at
Well,
that point.
a lot of this started with actually you're sending me the $120 Mercane Wide Wheel Pro.
That's right.
That was
Yeah.
the guy crashed it and it wires ripped out of the controller and stuff.
Oh yeah.
And that scooter was up and running. I think the day that I got it,
Mm-hmm.
and I didn't know how to fix it.
Hey,
I
who
just
knows
think-
how to fix it till you open it up, right?
Yeah,
It's
well,
great.
it's kind of like when someone says, "How do I know what I think until I hear what I say?"
Oh, that's a good one.
It's similar. It's kind of, you know what I mean?
Oh, that's a good one.
Yeah.
You got me going down a whole rabbit hole of split brain and psychology. Oh, total rabbit hole there. We could go for like half an hour.
And we will explore those in
Okay.
future experiments. But
Yeah.
feel free to bring that into this one too.
Mhm.
But what's our next step? You wanted to see what this did. Let's see what it does.
Yeah, let's see.
Now I
how many
haven't done.
volts.
I don't know that I've done. I don't think I've used this one.
Mm-hmm.
Definitely, I haven't used this one to charge this. So let's see what
Okay.
happens. Maybe stand back. Maybe
Sure.
close your eyes when I touch the wires together.
Okay.
Let's see what happens here. Because this is a lithium 18650, I think is what you're calling it, right? That's the typical.
Yeah.
So let's go back to our voltage here. And now let's set, what we'll do is we'll put all of our wires, these are coming from the full wave bridge rectifier. So those will go on here. Oh wait, we got to make sure the polarity, I'm hooking up to the right side. Okay, so let me check the polarity. Let me make sure I know what sides. Is it negative and more negative?
Exactly.
We'll just say negative and positive. And let me see if my meter decided to work right now with this one. I still don't know if the battery's dead on it or what's happening. Let's see.
It's in view of the camera.
No, it's reading
That's good.
millivolts, so it's not working. Okay, I need to pick up a couple more meters, I think.
Okay.
I need to pick up Cameron, let me know if you see any good deals on it.
Oh man, I wish I'd saved every multimeter that came across me. People give me stacks of tools. They say, Cameron, you're the tool guy. Here, take all this stuff, and then. Yeah,
Okay, I
pass it
hope
on.
this is giving me millivolts as well. This might be depleted right now. This might be totally shorted out.
Okay.
But to check, let's read this one, because we know earlier we tested this one. It was reading full still.
Mm-hmm.
And this is one that was depleted, and I charged it with the other system. Okay, so this is our meter is working. We're at 4.15 volts on this one.
Mm-hmm. And is there a way to determine which side is the positive?
I
Did you
think
already
it
determine
says-
that on this one, or?
No, I think it says on it. Let's just look for a plus and a
Okay.
minus. That magnet liked that
Oh.
battery.
Minus. That's got to be a plus, right?
Yeah.
Oh, whoops! Sorry, I had it out of the camera.
Yeah, it looks like it looks like a plus. Let's see. Yeah, it's a plus and a
Okay.
minus. Yeah, yeah.
Great.
So this is our plus on this side right here. Okay. Okay, so that's our plus. So that'll be the red,
Mhm.
which is this. This is red. Right through the rust and everything.
Mhm.
Hopefully that'll work. This is our other one. Let me go ahead and connect these
Mhm.
back up.
And this is volts. Is this saying
It's not.
it is?
It's not connected to the battery.
Oh.
It's
makes
still
sense.
connected to the old battery.
That makes sense.
So we're going to get probably millivolts right now. Let's see. 2.7 millivolts.
Millivolts. It's not volts.
Yeah, I think it's
Oh,
1,000. What is it? 1,000 millivolts make a volt?
I guess, yeah, milli is 1,000. So you want to try to charge it and just see if it does anything?
Yeah, but I don't know what's going to happen right now at all.
Mm-hmm.
So I don't know if this thing's going to go up in flames. This is lithium, okay?
Yep.
And
yep.
this is putting out, over 300 volts.
Let's say it does go up in flames. What's our safety procedure in this house?
Well, there's probably
do you
6
have fire
fire extinguishers in here.
Tell me where they are, just because,
Look, there's one back there. That's the nearest one. Behind. Behind. No. By the door.
Pow. Okay. There's one there, and okay.
Let me look where the other ones are. They're all over the place.
Let's say the battery flew.
Oh, right here. I have one by me. Right
Okay,
there.
cool. If the battery flew and it was on the floor, I would put this on top of it, and I'd want to slide something under it and take it out of the house.
Yeah.
Do you know what I'm saying?
And then we put salt water on it.
Okay.
Or soak it in salt water.
So if I put this on top of it and I want to slide something under it, what can I use? Like a
No,
piece
not
of
that stuff.
cardboard or something?
Yeah.
Just because if we're gonna mess around with this, let's be fully safe. No, I'm not gonna use your solar thing. Just like a piece of cardboard or cutting board.
You know what? I don't think
cutting board. If I need it,
Yeah, okay.
I'll run over and grab that blue cutting board. It's the battery. It's gonna get ruined. This is gonna.
I don't
ruined.
think it's going to
That's
do anything because remember, we're calling this intelligent charging.
Mm-hmm.
I don't think it's going to do anything bad.
Neither do I. I just want to be prepared.
But let's see what it does. And maybe let's see. Maybe something could happen. Here we go. We're going to test this now. 2.7 millivolts. This is a bad battery that will not charge. It just gets hot. So let's see what it does with this one.
I'll
Okay.
put my finger on. I'm just curious. If
I'm just going to tap it to see what it does.
Or go ahead. Do it, and I won't touch it yet.
Okay, tell me if it's getting hot or anything. Ready?
I'll do that.
Anything?
Nothing.
Look at our voltage. So again, this is showing how this thing on low, like it's on low speed right now, usually puts out around 350 volts AC. We convert that to DC here. This shorted out battery, which when I charged it with the other charging system, which saved all the other batteries, if I say it that way. It's safe to say it that way because the batteries are being used now. It looks like look at this. I mean, it's at half a volt right now.
What if we use the infrared device? Do you think that would work with the camera?
Well, yeah, it will. It will. You can do that. It's just that it's not, when you're close, see, it's an approximation.
Okay.
So you have to look for the heat. You have to, when you're holding it,
okay.
you have to kind of move it, like, you know what I mean?
Mm-hmm. Okay,
And
so kind of back and forth.
Yeah.
All right.
And if you're
I'll try it.
careful,
Let
you
me
can
see
get
if I
it
can
in
get
the,
it where the camera can see it, and
yeah,
then I've got
so just go like this. Yeah, okay, I see. Yeah, do it where you can see the...
and then the trigger button.
Yeah, and then if you push this one, it gives you the red dot.
Okay, I see.
And if you
so
can...
if I go like this, and
Yeah,
I'll
if
try
you
to
can.
get it so
Yeah,
they can
like
see
that.
everything.
Yeah, that's the way, if you can do it.
Yeah, right about like that. Cool.
Well, look, let me show you. Right there.
Okay, then when I'm on the tripod, I'm actually not seeing it, but that's the viewers at home will see it.
Yeah.
But I'm gonna put it right in there where I can't see it, but that's fine.
Okay, as long as the angle's not so great that they can't see it.
Yeah, no, I think people at home can see it, and I think we're good.
Okay, so I'm gonna move this down so I can show more of this thing here. Okay, here we go. We're gonna go ahead and do this, and let's just what we can do is we can charge this for. Let's keep an eye on the temperature. I don't think we want to go much over, 100 or what. Because these sit in the sun. They sit in the sun. In the sun, they get hot out there in the sun.
Okay.
But they're not having power put.
Oh, you're saying over 100
degrees.
Degrees. Yeah, sure. Well, if this gets to 100, we turn it off.
Well, I'm thinking because they probably get up to 150 in the sun.
I'm sure it gets well over 100 degrees in normal use.
Well, let's just see how it goes.
Yeah, let's see how it goes.
Okay, I'm gonna go ahead and start this. You ready?
Uh-huh.
That's at a big angle there, so it's hard to read on there.
Like so, maybe. I'm not really seeing any kind of great increase in heat or anything.
That's amazing.
That's great.
I
What
can't
do we?
believe- Look, it's at 2.
It's at 2 volts. I'll be curious to see if that drops right down or what happens. But look, we're down into the 70s in temperature now. Okay, so it's definitely not like immediately going up. How long are we running it for?
Couple minutes.
Okay. Trying to get the perfect angle here. Maybe
You'll get better at it as you do it.
Yeah.
You're already getting better at it, I can tell. You get coordinated with it.
Yep. Humans are the most flexible robot machine in the world. Humans can really adjust to anything.
I think the universe is also the most flexible.
You deal with what you've got right then.
The most
You know?
flexible robot in the universe.
People who aren't flexible are in trouble. Yeah, I'm seeing consistent 80 plus or minus 1 or 2 degrees or something. 83, 84. Interesting. Over here it's 85. Oh, right there it's 85. The hottest part is there, but it's not very hot. Right there.
Where is it?
Right there is the hottest part.
It feels like room temperature to my hand.
Yeah. 85, 86. And the rest of it's...
It might actually be the plug that's hot. This. Because this thing's not, if you touch it, it's not warm. It's not even warm.
Yeah. Even, I mean, 80 degrees doesn't feel too warm, really. I'm feeling like... I'm going to do fingers. And if I feel any heat, then I feel heat. But I'm saying no heat. What about the wires? What about this stuff? Have you ever measured your
Yeah, this gets warm.
device?
Yeah. It gets warm.
129. That's pretty typical, though. It's things that are moving energy. I've had them
Try this
get
one.
up there. Even less, 94, 95.
It's got the fan on it.
Oh yeah, okay.
Okay, we can stop it though.
I wonder what the phone is. The phone's still 80 degrees. So
Okay, so let's see what we have.
what did we get to on our volts? Is that volts? Is that
Yeah, that's half a volt. That's
0.6 volts.
0.6
Okay.
volt. So it did, this is amazing because this battery, if I put any power in it, even with the other charging system that I'm talking about, the one with the outrunner, remote control, airplane, and helicopter motors,
Mhm.
even with that one, which saved all the other batteries,
Mhm.
that this would get hot when I would try to charge it with that one, if I put any power into it. And with this system, it's not even warm. It's literally room temperature, like when I touch it.
Mhm. Yeah, it didn't appreciably change.
And look at the voltage. This was at, what was our millivolts? What was our millivolts on this originally? Wasn't it like really, it was super low.
It was very low.
It wasn't
I
in
can't
the
tell you
hundreds.
exactly what.
It wasn't in, I think it was, I don't know, I don't recall what it was, but it wasn't in the hundreds. We're at 500 millivolts now, half a volt. That's a lot more than just a couple millivolts. I feel like the millivolts was just at like 2.5 millivolts or something. It was really low.
Mhm.
2.5 millivolts.
Mhm.
I think it was something like that. So now we're at 500 millivolts. So that's a significant improvement for a battery that's just completely no good.
Mhm.
You know, and I don't know what that means. I don't know what's wrong with it inside or what happened. But it does make me wonder if we just left this on the, running all night, like what would
Yeah.
it do,
Will it just charge up, or will it charge up to where its health as a battery will charge up to? I guess that's its potential. Is if it's damaged, then maybe
Yeah.
it only can get to
a certain point.
3.2 or
Yeah,
something.
yeah.
But
But I like that this
Yeah.
is totally, and do you agree with me, when you touch it, it's room temperature?
yeah,
Touch it.
it's not noticeable at all. In fact, this iPhone 5 that I've been using for a little while, it feels hot to the touch. Okay, let's see what...
You can't see the number on there.
There we go.
Yeah.
103 degrees. This phone got up to 103 degrees, and you can feel it, but no, that battery didn't get to anything.
And is that because we were because you're using it.
Using it for 15 minutes, but since the battery is too bad, it was just running out, so I just turned it off. What do you think about replacing this 18650 with something
that's charged already,
like this, and just see what happens?
So this comes from the same. This is the same scooter. And so these were also, water damaged and totally dead, or almost completely drained, and charged these up with the other charging system, the Outrunner motors, and I'll bring it over one more time. Those were charged up with this system here. So this was the drive Outrunner motor, the drive motor, and this one being the charger, and this going into into this actually. That makes it easy. I could just show you. This converts, so this is releasing, if I say it that way, AC. This converts AC into DC, and it's just a bridge rectifier. This is just the one I used from Amazon. Again, thank you, Amazon. So, and this system was used to bring this charge up. And this has still been holding a charge. It's been a while now, over a month at least, and it's just maintaining a charge. But yeah, we can see what this does when we put the power to it. Let's go ahead and do that.
Now, what do you think about buying materials versus finding materials? Any difference between new materials and found materials?
I really liked what you said about today earlier before we started streaming, and we apologize we didn't start the stream sooner, because we were having this conversation for a couple hours probably.
Yeah, we were. Yeah.
And we talked about all kinds of things related to energy, and you brought up the idea of, did you call it natural experiments?
Natural experiments, which is what I was taught in college, traditional education. Find something, let's say you want to make a new experiment on your own, but it's expensive and you need space and you need materials. Why not find something in society that replicates that already, and you can just take that scenario and you can use that as your experiment. It can work with data sets, or it can work with physical things in real life. Like we were discussing the going in the mountains and finding a guardrail. And I don't know if you can explain it better than me if you want to explain it.
Go ahead, I'll come in when you're ready.
Okay.
Yeah, go ahead.
So Joseph was telling me that
in my studies of of Donald Lee Smith, Resonant Induction Energy Transfer and Earth Electrical System 2. Don Smith introduced this idea. Go ahead. And Don Smith was also, I'll say it this way, a student of Tesla, in that he studied everything Tesla did and replicated not only, I think, everything Tesla did, but went beyond.
Okay.
Yeah.
And what we were discussing is that if you were to ground a wire into the ground and then take the end of the wire, however long you have that length of wire, and you raise it in elevation somehow, for instance, going up a mountainside, if you were to measure the voltage difference between the ground, and you get a ground by pouring salt water into a pit. I think you even put coal in the pit. I think I've heard about that as a part of making a proper ground.
Okay.
Could be wrong about that part. But if we were to take a natural experiment and try to do this, I thought, what about a guardrail in the mountains? We drive up to Angeles Crest, we find the longest guardrail with the most elevation we can, we ground the bottom end we probably get battery jumper cables and clip them to the guardrail, stick the other ones in a pit with salt water that we've dug out in the ground, properly ground it, go up to the top of it at a higher elevation, and then measure the difference between the ground voltage and that metal guardrail voltage. And from what Joseph was explaining to me, we should be able to have what's the result? Volts, amps. What do you get?
Amps come in after the load.
Okay,
so it depends on what. Yeah, you're going to get voltage, and then if you want to run something, we'd have to see what the amps do.
Okay.
But when we're trying to power something, we have to just read the amps.
Okay.
Don Smith refers to amps as being after the fact.
Gotcha.
To use his words.
Mhm. And I like,
yeah.
I think natural experiments are good because you can be lazy. Not that being lazy is that useful, but there's no reason to reinvent the wheel if someone already invented it. I'll just go get a wheel.
I like that. So I really like the idea of the natural experiments. And yes, just to
Mhm.
clarify from what I understand about that, if you're using a guardrail, you call it, right? A guardrail?
Mhm.
Um, I think it's important, from what I understand, and this is just the way that I understand it. I could be wrong, but I'm just going to share what I understand. Uh, it's important that the only places that the wire is actually in the ground is in 2 points. So if you're using a fence, it would be important that the fence is not metal going into the ground all the way up the mountain.
Mhm.
It needs to be, like, guess, wood, and I also don't know if the wood was wet,
Okay.
if it could still conduct. So
Uh-huh.
way I would like, we can try that. I'm willing to try a pre-existing or a natural experiment, as you called it.
Mhm.
But whatever those results are, positive or negative, I would also be interested in running, a wire, like, I don't know, 1,000 foot of wire or a couple thousand feet of wire,
Mhm.
up a hill or down a hill, whichever way you start.
Mhm.
Have a pole driven into the ground. So I don't know if we'd use a copper, stake or pole, or
Mhm.
just a metal pole, but
Mhm.
we could try copper. We could try, like, iron, like that magnetic iron that goes in
Mhm.
there. We could try both. Pour, make sure the ground, that pole has salt water around it to help it connect to
Mhm.
earth. And with an elevation change, so having one pole at the top and then go down the hill a bit or a lot and then have another pole there. But important, not letting that wire touch. Or the idea is that it would be like a flash bulb.
Mhm.
So if the wire touched both of if that one wire touched both of those poles, it would just vaporize it. That's the idea,
Mhm.
because there's
Mhm.
so much energy there. I haven't tried this yet, but I'm interested in
Mhm.
seeing what the results would be. And
Okay.
so we need some way of measuring the voltage. So the wire would be connected to one pole, and then you would read the voltage between the end of the wire and the other end of the pole, the other, whether it be up the hill or down the hill. But what I was thinking was, instead of just going 1,000 feet or several thousand feet and having all this wire, I would slowly go up the hill and just keep taking readings, which would
Mhm.
require me driving stake in, pulling it out, driving it in again.
Mhm.
But that's okay. Maybe we can find some soft dirt, or just have
Mhm.
some way, have a shovel and have
Yeah, have
a
some
good
rebar or a sledgehammer,
yeah, have some
something like that.
tools that
Yeah.
would allow us to not
Yeah.
be too difficult to do that.
Mhm.
And then have a couple gallons or a couple buckets of salt water with us,
Mhm.
and just see what the voltage change is as we go up the hill. So that way we don't go to a voltage so high that it damages our meters, right? Because
Yeah.
meters, like, I don't know how many hundreds of volts these go up to, but maybe 500 volts, 600 volts.
Mhm.
I don't know. Meters vary, but I don't know if they go up to 10,000 volts
Probably not
or
gonna work.
50,000 volts.
Yeah.
So it's an idea, but like I was saying to you earlier, I was like, Cameron, I really want to use this knowledge that we're learning about, right? That we're learning through experimentation and studying other people that have come before us.
Mhm.
I really want to relate that knowledge to as a range extender for the scooter,
Mhm.
so that I may not have to have so many batteries on it.
Mhm.
Because I don't know. Tell me what your thoughts are about this, because we talked about renormalization,
Mhm.
how that's kind of like saying, well, matter particles are just charged.
We just charge these, and that's all that happens.
Yeah,
It's kind of like the fable. We're getting into the talking in fables where you have to ignore the fact that everyone's made out of atoms, which are nuclei with protons and I don't know, whatever. It's got protons and electrons spinning around a nucleus, and that's energy, that's movement, and yeah. So renormalization is ignore that there's energy everywhere. Just consider the effect change that you did on these particular electrons right here. That's the fable. But I think the fable is people hear that information and then they say, therefore, this is all there is. I think that's
still good.
the fable.
It's still showing
Cool.
the stream. I was just doing a test. Sorry, everyone.
Great.
I'm listening to you, Cameron.
Yeah, I think it becomes fable when you decide that you've learned a few certain things, and you decide, hey, these are working for me. That's all there is.
Mm.
I really like my ZX7 motorcycle. That's all there is.
Okay.
You know, I
Yeah.
mean, there's a ZX11. We all know that.
Yeah.
I'd rather have the ZX7, but it's not all there is.
Okay. So thank you for explaining that. It makes sense. And I'm sure all of your students are extremely grateful for your knowledge.
My motorcycle references at any moment. Hopefully.
Okay, so what? Okay, so was there more to say on that?
I think I'm good on that.
Oh, I think I was going somewhere with what I was saying. Let me think of what that was. Well, it'll come back. I think it was
Sure.
atoms. What were we talking about before that?
Oh wow, Joseph, we've talked about so many things. It's actually, see, the thing is, my career is not doing electronics, even though I've always worked with tools. I've always worked with electronics since I was a kid, so to me, it's so exciting. I get excited in my stomach when I do this. Like, I think about, like last night, I was like, me and Joseph are going to do science all day. And I'm like getting fluttery stomach, like so excited because, hey, I think this is great. I dreamed of this technology a long time ago, and it exists now. You know, these lithium batteries exist, and they're here for us to play with and to harness their power. But I think one thing we thought about doing, maybe a distraction here,
No, go ahead.
was forgetting charging this guy, which we think is defective, and seeing what'll happen if we measure the voltage on these, which I think we did. These was like 4.1 volts or something. And
Yeah.
maybe charge these and just see
what it does.
what it charges at. I mean, I doubt it's going to say it's charging at 500 volts. I predict it's going to say it's charging at 4.25 volts when we connect it.
And I even wonder, because we're going to take a voltage reading on this set here now.
Mm-hmm.
Anyway, and these are all in what I think is called parallel. So this is like a set right here.
Mm-hmm.
So when the battery management system balances this, it takes the voltage of all these and it brings it to it keeps it at a safe level.
Mm-hmm.
It keeps it from going too high. That's just my own way of saying it. I don't know how else to say it. So what I wonder is, we're going to read this right now. We're going to take a reading on this, and I do wonder if the voltage going, so at first, is it going to be higher or lower than the battery? And after a couple minutes, is it going to be higher or lower than the battery? I just wonder. I wonder that. But let's see what it does. Let's just see. This one's already full. This battery was filled a while back, and we're going to see what the voltage is on that right now. So let me try not to arc anything. Would you take this one and set it down? Okay, let's do our. That looks like a positive to me on this one. On this, is this side positive?
Yeah,
You see a positive there?
Is positive.
You see that on there?
Yep.
Yep.
This side.
And the other side says negative?
Correct.
That would be logical, right? So that means we're going to connect like this, and I'll just connect it like that. I can connect here. I can go into that. So that's now connected to all those. And then this side, we'll do the same thing. And that connects to all these. And that's called parallel. It's like all the negatives are on this side, all the positives are on this side.
So this is a 6P thing.
Oh, okay.
Set?
Interesting.
I don't know what we'd call it. Group?
Yeah. So let's go ahead and turn this on. Volts DC. So we're at 4.13 volts.
Okay, 4.13 volts.
Yeah.
I predict it's going to go up to 1/10 of a volt or something. But I wonder where it goes after that.
Well, I don't know. Let's see what it does. Okay, let me see what's happening here. I apologize to everyone for messages coming in. You know, I have this on Do Not Disturb, and the message still came through.
I've found that not everything is perfect.
Yeah, so that happens.
In the internet, definitely.
I apologize for that. Okay. So we're going to do a test. Oh, what was I going to do with this? I was going to make sure the stream was still visible. Because the last stream we did, we lost picture. Oh, it's making me watch the whole
Well,
commercial.
we've got the Infinity advertisement. I'll make
And-
sure to buy that so that your channel earns. I'll buy myself a new Infinity tonight.
Okay, let's just see if we're still. This is just for testing to see if we're. Yep.
There we go.
Okay, so we're still visible, and hopefully it stays that way when we after the stream is done.
Mm-hmm.
And apologies for that last stream that lost video but kept sound, even though I am grateful the sound is still there. Oh, are we low on light? Would you
Are we?
please turn that on? I
Yeah,
didn't even
yeah.
think of. Now, we can add
What's
some
that?
light now that we're at the end of the. Well, now we can go for a couple more hours, right?
Yeah, let's do it.
We still have light, Cameron.
Hey, we still have 462 other batteries in here to try, Joseph. So
Yeah, and we're at
We're here all
4
night.
volts. We're
All right,
good.
yeah. We're
So
at 4 volts, and
4.13 volts.
and it's consistent. It's not bouncing all over. So
Yeah.
you know, it seems like a solid.
Okay, so do you want to talk about what we're going to do right now? Do you want to do that?
Well, I think what we're gonna do is we're gonna try to. I wouldn't really call it an experiment. I'd call it an observation. I just want to see what this does. I want to see where the volts go when we turn the machine on.
Yeah, and
It's
we
just
talked.
basically what I want to do.
And before we streamed, we were talking about not because we were talking about the idea of proof. Like you said, let's
Mhm.
prove, let's prove, let's prove. And I said, you know, Cameron, I really prefer to not prove and rather just explore and share our exploration.
Mm-hmm.
Right? Is that the way I said it? Something
Yeah.
like that.
Yeah.
And you liked that idea, and it
Sure.
just feels better too, because
Proof
we.
sounds so official, but
Yeah.
hey, maybe we'll prove later, and explore now and prove later, or never prove. But the reality is this: I've hung out with a lot of people in my lifetime, and spent a lot more time working on, whether it's a bike, a motorcycle, a car, welding a go-kart from scratch, building a roll cage, rebuilding an engine, whatever it is. There are a lot of people who won't do that stuff. So I just appreciate working on stuff hands-on, and Joseph actually has a goal here, which is to charge a battery. So instead of us just randomly touching wires and batteries together, we have a goal.
Yeah, that's the goal.
Charge a battery.
To charge a battery in the most efficient way we can.
Mm-hmm.
And as we discover more efficient ways and more efficient ways of charging a battery, at some point, that approach can be applied, I hope, to the scooter.
Mm-hmm.
And
I can't wait to see.
and wouldn't it be fun to ultimately do it to something larger than a scooter, but another
Mhm.
form of transportation, right?
Mhm.
And that would be interesting too. So for the rainy days, right? I mean, I know
Sure.
we have the umbrella. We
Yeah.
got the umbrella, but we don't have air conditioning and heating on the scooter yet.
It's true.
Okay, so let's go ahead and see what happens.
Mm-hmm.
These are connected correctly.
And these
Positive
guys
to
are connected
positive.
to the
Negative to negative.
rectifier, and the rectifier needs to be connected to this guy,
Oh, what's this? This
right?
is our charging. Thank you.
Okay,
Thank you.
sure.
Yeah, this wasn't going to charge if we don't have these connected.
We'd find that out though.
We would when we didn't see
All
the thing.
data is good data. The thing is, I do like saying, oh, I like science, but what I like is, if you're doing science, you're doing it right. If you don't get the result you wanted, you're doing it right.
I like that.
You're never doing it wrong. Even if you break your toy, you break your motor, your battery, you're doing it right. Because you learned.
Because you learned.
You can never do science wrong. I mean, you can do it way less good, but it's hard to get bad. There's no bad data.
So what would you say? Now I shouldn't even say this, but I'm going to say it because I'm just curious what you'd say. What would you say to someone that says, "Prove it to me"?
Prove that you can't do science wrong, or prove anything to me.
Prove anything. It could whether it be science or just if they're just like show me, prove it to me.
If they really need me to prove it to them, I might tell them I don't care if they know it. Because if I know it and I can use it, if Joseph's charging his battery, it doesn't as much matter that someone knows why. I mean, it's back to the fables. You could tell them a fable about there are elves inside of it doing it. We don't know the difference. I've never seen an electron. I never have. I've talked about them. I've taught it to kids. I've never seen one. It could be totally like something else in reality.
I like that. Okay, so your answer is, well, if you want to charge batteries in a similar way that I do, then just look what I did, and then go do it. If you need help doing that, then we can talk about that as a separate subject, right?
Mm-hmm.
In a way.
I mean, what if someone said, why does this flashlight work? I've got a battery, I've got a switch, I've got a bulb. And someone says, why does this work? I'd say, well, there are invisible elephants going from this to that. And see how the invisible elephant is opening its eyes at the light bulb? And then I could get someone to repeat that. They could share that with other people of generations. How about that for a fable? I'd rather not tell you a damn fable. I'd rather just do my experiments and have success.
That's great.
If that makes enough sense.
That's really, I really appreciate that. And I'm just curious, is this light dimming?
It's probably dimming. It's a cheap, $10
But it's
thing.
still giving us something.
It's got a
so
little light.
It's now a fill light, right? This
Mhm.
is our main light now.
I predict this has one of those little pouch lithium packs in it. You know the little pouch things from the tiny RC cars?
But are you sure there's no elves in there powering it? That's the question.
Change your video name. Are elves doing this? The Elf EMF channel.
Oh, Cameron, you make me
Nice.
laugh so much.
Nice.
Okay, this is fun. We're going to do our test now, Cameron. Would you like the honors of powering this one?
Oh, I'm too scared. I wouldn't want to mess it up. You go ahead.
Okay.
You got your finger close.
So, you're in charge of the fire extinguishers,
Yes.
the framing of the camera,
Yes.
and letting me know if you see smoke.
Sure. And you know what? I think I'm going to ignore this guy. This didn't wind up being the greatest. I'm going to just keep this out of the mix. I'm going to touch it with my finger. I'm going to observe it, and we'll go like that.
Yeah, and I don't mind doing this because I really enjoy the challenge of the angle
Cool.
of getting it where you can see the red dot and you can still see the temperature. The
That's
other one
doing
didn't
pretty good.
change at all, though. It was
did
putting
not.
power in and it didn't change.
I would say that on one end of it, it got to 85, and the other it was like 81 degrees for
But-
whatever reason.
But do you agree that when you touched it, you didn't feel a temperature difference?
Nope.
So I wonder if the meter
Insignificant.
was picking up something on the connector. I just wonder that,
Mhm.
if it was over
Mhm.
here. I don't know.
Or who knows, it may have been picking up the damage inside of the cell. It may have been localized, like one end of the cell physically had lithium damage to
Okay.
it, you know?
Yeah, that's possible too,
never know.
yes. Well, I'm glad that we did the reading that way
Uh-huh.
to show us that. So it's kind of documented for us. And when I say that, I mean documented for us, but shared with all.
Mm-hmm.
Because that's what
Mhm.
this is. We're just sharing our learning process.
And not everyone has this stuff, you know? This can help people because it takes a lot to get this motor, to get this motor, to get this potentiometer, to get all of your multimeters, your wires, your batteries. This wasn't just you get it in one day. You didn't
Yeah.
order on Amazon yesterday, did you?
No.
You've probably been acquiring everything right here. I'm
Yeah.
gonna guess it took you years to get everything that's right here.
Yes, but
At least a year.
yeah, it did. It took a long time, but it was. If you ask me why it took so long, I would say I was doing many other things between that time.
Mm-hmm.
Like it wasn't like I just built this. You know, how could I say it? Do you know where I'm trying to go with this? Like it wasn't like I was waiting for parts for a year. You know what I mean?
Mm-hmm. Well, you're getting to it over time. You're building your knowledge over time. It's stacking on top of other knowledge. You're getting to where
Yeah.
you know. It's not like you only did that on a Monday and then waited 6 months till you found another thing on a Sunday. You kind of live this life. You live a lifestyle of experimentation and thinking
Yes.
about it and reading about it, researching and sharing. So.
Yeah, I think what happened was I think it got to the point where I was ready to see what this can do for
Mhm.
myself.
Mhm.
Because I was studying the theory of it, or what's thought of it so far,
Mhm.
that is shared. And I know there's a lot more to it than that. And that's with everything.
Mhm.
Right?
Mhm.
Truth is stranger than fiction, right?
Oh yeah.
It's like, you want a really good story? Just
Go to the truth.
go to the truth. You're going to get something that's going to totally blow away any fiction that you've ever seen or thought of.
I literally never go to fiction. I can't get enough truth. I just give me truth every day.
Yeah.
I've got no time for fiction. Fiction is just like socializing and hearing people's stories in their lives, like hearing how cool they are and they make it up. That's the fiction.
Oh, that's so funny the way you said that. That is so funny.
I probably give people a little fiction about me, but you know,
Okay.
I'm not perfect.
Should we do this?
Let's do it.
Okay, let me know if you sense a difference there.
Mhm.
I'll tap it at first.
Cool. wow, that voltage isn't changing. Maybe this thing already has its homeostasis and it's doesn't need anything. Is it connect? It's connected?
Let's double check.
This is all connected. It's all connected.
Negative, positive, positive.
It's on the metal. It's on the nickel strip.
Meter's connected to everything. Okay, let's go ahead and let it run a little bit then.
Yeah.
Shall we?
Yeah.
Okay.
What do you think would happen if we yanked the wires in the middle of it? It would just pop up to 500 or something? Pop up to 400?
Or blow the meter out?
Yeah.
I don't
Blow the
wanna-
meter out. Let's not do that.
I mean, people break a lot of meters with this.
Okay, that makes sense.
These experiments break meters.
It's
Yeah.
it's a very variable kind of idea, and I'm seeing no change here. And like you said, these batteries were charged.
Yep.
It's not changing, so I think these have accepted everything they're going to. And so I wonder if more heat is going somewhere, or where's the energy? What's getting shoved where?
Good question. Let's see if it changes at all. Can I turn it up?
Yeah, why not? Wow, not even a hundredth of a volt change. Because this thing probably says, hey, I've got my homeostasis. That's really interesting.
Look, it is going up a little bit. Watch.
Does it blip a 5?
Yeah.
Yeah. I wonder if we need to find a pack like this that's not as fully charged. Something that's not dead. But no, you took your time and charged every battery you had on. Okay. What is that? Even something like this, you got fully charged?
Yeah.
Okay.
But we could
I do
charge
the
the
same.
bad pack. We could charge the dead pack.
That's it?
Yeah. No, the other one.
This one?
That one.
This one.
Yeah, we could cut the wires and.
Oh yeah, that makes sense. Because we knew that was reading at like 3 or something.
Yeah.
Maybe. Oh, I see. It had 5 for a little. Okay, maybe it is going up a hundredth of a volt. Well, look, we went up a consistent hundredth of a volt in what, 2 minutes or so. So it's probably like a diminishing returns thing where if the battery's almost full, it's going to take longer to top it up by a hundredth of a volt.
Yeah. Yeah, it makes sense.
Okay. Oh, look, it's bouncing around the 4s again. I thought it was going to stay at 4.15.
But it's definitely moving in the direction of charging. Like it's definitely doing something.
Yeah. Yeah. What do you want to try next?
Should I turn it off?
Sure.
That was high. Okay. So that was interesting. So this one was already full and it just didn't seem to It seemed to know that, I guess.
Yeah, it was
Is
just
that a,
right next to what it had been, but increasing by 100th of a volt.
did you want to try this one, or what do you think? This is a
Yeah, I think that'd be useful.
okay. This is a battery that um, we'll read it right now. See, this one makes me want to pull out the other charger for it because that one charges them fast.
Ah.
This seems to charge it slower. I don't know. Oh, we wanted to try putting the neon bulbs in series.
Yeah.
Okay,
With
well,
what? With charging.
with
this
charging
or-
something, but we can try it
Okay.
with charging this one. Okay, so what do I
Yeah. We could charge this with it because this one still has a little bit to climb, or that. Either one.
Okay, so we're opening this up. This wasn't working anymore.
Yeah, this was a power bank that stopped being able to charge over time. This was mine a couple years ago. And my idea was to harvest the USB charging circuit board out of it. And Joseph thought, oh, well, let's also harvest the batteries out of it for now. So apparently we get to take everything from it.
Okay, so I'm gonna cut the wire. Is that okay?
Yeah, definitely.
Okay, so we'll cut the wire here. Got it?
Mm-hmm.
Thank you. Okay, let's go ahead and see if I can take this off. Oh, how interesting. Look at what color the cells are.
Same cells.
Is it the same cells?
Is it the exact same?
I can't believe it.
Like an M365 cell?
Scooter batteries.
Yeah.
Or are the scooter batteries power bank batteries?
Yeah.
Which way did it go, right? Okay, so
Well, if it had the same markings, that would be really interesting. That just
Well, let's
everything was
see.
the same. Could that be?
can
Because
you
look at this, M365 battery, purple cells. Here we go, purple, purple everywhere you go.
Yeah. Well, let's look. Let's look at can you see?
Oh wow. Man, I think I need a new prescription to see it. I need like a magnifier.
You got a magnifier right here. Interesting. Okay, so let's set this down
Mm-hmm.
and let's go ahead and let's see. Okay, so we were thinking about trying some experiments.
This is nickel strip here, so you've got easy leads to touch. You don't need to strip the wire ends.
Yeah.
Okay.
Let me think about this for a second.
Now I can see the numbers actually.
Okay, let's just see what happens, okay? Let's see what happens. This is my thoughts. I want to hear what you think too.
Uh-huh.
This is our negative. Okay, negative. I don't know. What's this? What are all the...
This
Oh,
is
we got
the
two negatives and a
rectifier.
pause. Okay.
Uh-huh.
So I want to put a couple of these in series. Oh, that's what the soldering iron was on for. I was going to solder some of the
Okay.
whites together. I couldn't.
Are we going to do it first and then try it with those in series?
We could try it a couple different ways, yeah.
Okay.
So
And you're going to put the two 220 volt neon
Yes.
bulbs in series so that you can hopefully not pop them when we give it 380 to 480 volts, right?
yeah, so I'm going to want to probably keep this on low because on low it's 350 volts, which would be within the parameters of 220 times 220 twice is
440.
440, and I think these are 220s or
Okay.
210s or 220s. I'm just going to solder these together, and these are the neon bulbs.
Mm-hmm.
I wrote the company and asked them if they're in a vacuum. I wanted to know if they're in a vacuum and what gas is in there. All I know is they're calling them neon, and there's a gap between the bulbs. And Gerard Morin refers to the neon bulbs as an improved spark gap. So I want to experiment with that and see what happens, because I know a spark gap, according to what Gerard Morin and many other researchers have shared, is that a spark gap is a magnification and amplification of energy. And it also increases the frequency.
Mm-hmm.
We were talking about that earlier. which makes sense. If there's a spark gap, and all matter is being charged at 10 to the 120th times per second, from what Thomas Bearden talks about. He's a scientist that shared a lot of his thoughts and experiments. It makes sense that when you have a spark gap, that the frequency would increase. In a way, I don't know what the connection is there.
I personally don't know enough to know, but
I mean,
know you've read more than I have.
Well, that makes me think of the transformer, right? Because there's 60 cycles per second coming in to the transformer on the power lines, but then we still get 60 cycles per second from the transformer to the house. So somehow that's maintained. So I'll have to, maybe think about that more, or maybe we'll discover what that is in our experiments. We'll just learn it,
I was curious. I mean, I was interested in the spark gap because there's a device when people are building their own e-bike or electric scooter. It's I wish I could think what it was called now. It's like a spark connector or a no anti-spark switch, where when you connect a battery, let's say you're connecting a 48-volt battery to the controller, when you connect those wires together, it sparks, and then that causes some damage to the connections. So that took me to...
Oh, because it's charging the capacitor, right?
Because it's charging the capacitor, but it zaps it, and it's kind of like using a welder, but you're using a welder on your connections.
Okay.
So it makes me think to welding and using a MIG welder, which I believe it stands for metal inert gas. The inert gas being argon gas. And so when you weld using the MIG welder, it's got wire being fed to fill in the gap between your metals, but also it has this gas being blown at the area that being fed to the area you're welding, and that prevents, a bunch of burning and contamination there. And so I'm thinking, this being in a vacuum or having neon gas inside of it is going to prevent excessive burning of the terminals, and so that'll last a long time.
That's your thoughts?
Long story short. Yeah.
That's your thoughts on it? Okay. Okay, well, that's my soldering of the neon bulbs in series, and I just...
Nice.
Because these are AC, I don't think there's a positive and negative. It's just either way. So, and I was noticing these were the same length. Like in LEDs, one will be longer and one will be shorter, and then so one's a positive and one's a negative. I've noticed that. At least that's something I noticed, but I don't know that it's always the case. But
do we need any tape over this or anything, or it just run it as it is?
What?
Over your connections, do you need to put any insulation on there so that it doesn't touch anything else, or
I'll look at
set
it
on the table and run it as it is?
I'll look at it in a second. I'm thinking set it on the table, but let's see. Okay. Oh yes, thank you for asking. These get very, very hot. The other day when I was testing one of them, now I was putting 350 to 475 volts into it, and it's only a 210 or 220 volt neon bulb. It was getting over 500 degrees according to my ability to read it with this, which was, I'm not sure I had it perfect, but it was, the temperature would be close to that. Let's get this ready for connection by stripping the wire off of this. So let's just take some wire off there, and insulation, I should say. We're taking insulation off. Take the insulation off there. Okay. Okay, now I'm not getting, let me see if I can show what I'm doing here, yeah. Okay, so we're going to just twist that. Now this battery, I think it was at 2 volts or 2 point something. We'll check right now. We'll read it right now and see what it's at. Okay, so this battery was donated to Science by Cameron. He donated to Science a couple months ago, actually, and we're going to see what we can do with it right now. So let's see. Now, I don't know whether to go to the positive or the negative. I also am not sure I'm going to use the meter right away because my other meter didn't like that I was doing that. Let's just read temperature at first. How about that? We'll just keep an eye on temperature. So let's do this. We have so we're going to go, now let's see. Now, do we go on the positive side or the negative side? Right. Do we go in series with our bulbs on the positive side or the negative side? And am I even thinking of this in the correct way?
And you want it between rectifier and battery, not between your machine and rectifier?
You know what? I think let's try going between. I am also wondering if I should do 3 of these in a row, but I have plenty of them if it burns out.
Mm-hmm.
Should I try 3 right away?
I think, I don't know, if they're 220, I would try 2, because I
Okay.
feel like that's the ideal. If it's 440, you know, if 440 is how much they want, we can dial it exactly to 440.
And we know the voltage drops down anyway when it's connected to the battery.
Yeah, I think if we had 3, then it would be wanting.
I don't even know if
660,
these will light up.
They may never turn on.
Okay, you know what? I want these in the air. I
Yeah.
don't want these laying on anything because in case
Okay.
they get super super hot. So let's just see if we can keep it like that, like floating kind of there. Mm-hmm. And then let's see how we're going to do this. So we'll go there, and then I'll connect this one. And then from there I'll go to the full wave bridge rectifier, which converts AC to DC.
If I tuck this under like that, it might just kind of hold it. Is that fine with your wire to kind of
Yeah.
manually hold it that way?
Mm-hmm.
Okay.
That's a good idea.
I like those little station things with all the clips. I haven't gotten one yet, but I swear I'm going to get those glasses, and I'm going to get the clip station. And
I'm glad you just said that because we need that for these to test.
Yeah.
And I think I'm going to...
It's pretty useful.
That's something we can collaborate on too
Mm-hmm.
for our next, maybe on our next...
Make a note of it, actually.
our next Chipotle stop, right?
Yes. The Chipotle files.
The Chipotle files, yes, we like to eat there. And that's not a... We weren't paid to say that.
I think we should be paid to say that. I think that's our goal can be to charge batteries and to get free burritos.
Okay, you can do that, Kevin. I just want to learn. That's all I want to do.
Sponsors.
You can have my burrito, okay? My vegetarian burrito. I'm trying so hard to be a vegetarian. I'm doing good today, I think. Okay, so
So we have set
let's
up
see. What's
the
happening
neon
here? This is our meter.
is going between the machine and the rectifier, and then the rectifier is going to this battery.
Yeah.
And we're going to read what this voltage is for the folks at home before we run it, are we?
Yeah, for sure.
Okay.
What I'm concerned... Here's my thoughts, though. Because this seems... If I just say it this way, this knows what the voltage is. Like, it's some... Right? Because it matches whatever we plug it into. It doesn't go above its maximum voltage.
Mm-hmm.
And sometimes it goes right to its maximum voltage or just below it and then drops a little bit, which is really interesting. So if it does that, how can this even turn on, and will it even work?
Ooh, good one.
I don't know that it will. I also don't know if it'll... Let's just see what happens. We're just experimenting.
Is good data.
Yeah, we're just experimenting.
Great.
I just hope I can grasp whatever's happening and whatever's not happening. That's what I really hope, that I can grasp that. Let's go ahead and do what you said, which is a very good idea. We want to read the voltage of the battery, because we haven't done that yet. So I'm just going to touch it to these, and that'll give us our voltage, our battery voltage. 2.8.
Yeah, 2.83. All right.
2.839. Now I'm going to unplug this only because I don't want to risk burning out the meter at the moment because we're doing something new.
Good.
And the last time I had those connected and tried to read voltage with those connected with a different experiment that was similar, my meter just hasn't been working correctly since then. And I don't know if it's coincidentally the battery's just low and it's not working correctly, or if something's actually wrong with it. We'll see. Okay, I'm going to go ahead and turn this on. Are you ready?
Sure.
Okay, and just, I know you know this, but don't look at, if these do turn on, don't look directly at
okay.
them. They're red, and on Google search, it looked like it was saying red is good for the eyes, and it even can heal them,
Okay.
but let's not look at them.
Yeah,
let's
cool.
just be safe. Okay, I'm going to touch it. I'm just going to touch it on there, okay? Ready? Yeah, I'm doing something new, so let's be
Cool.
as safe as we can. I can't believe they're lighting up.
I saw a light.
I can't believe they're lighting
It
up.
didn't seem super bright.
Cameron, they're going to get bright. I touched
I'm gonna
this.
burn my retinas for this, Joseph.
Cameron, how did those light up? We're charging a 4.2 volt battery. These are 220 volt.
It's on the machine side of the rectifier, right? I wonder if it would work on the battery side of the rectifier. But
We'll test that. We'll test that. We'll test that. Yeah.
Just run it for 5 seconds. I just want to kind of like look at this thing. I'm just curious.
I am feeling like it's going to burn the bulbs out.
Well, if you don't want to run, if you don't.
No,
want
I
to
got plenty. I got a bag
That's
full
cool.
of them. These are the bulbs, and by the way, this is the bulbs. This is the.
Gotcha.
This is the bulbs from Amazon.
What do those bulbs cost?
Oh, they were around $6
Per bulb or for the?
No, the whole pack.
Oh, okay.
It was less than $10. The price changes based on color. The colors are red.
Mhm.
The blues cost more, and there was
Okay.
another color, but the prices can also change from day to day. That happens too. So
Yeah.
when I bought them, there was, and I think I had a coupon too, but they don't cost more than they cost around $10, around 10.
Mhm.
But I think when I bought them recently, they were about around $7, $6.99
Okay.
approximately.
So we're not going to.
That's Amazon Prime, though.
In parts.
That's Amazon Prime,
Yeah.
so I don't know if that's also makes it less. But
Okay.
I can't believe the bulbs are lighting up. I'm excited.
Mm-hmm. Do you wanna just move them to the battery side before we burn them out? Because now you know they fire on the rectifier side. Move them to battery side.
No, I want to charge. I want to charge that
Charge it
battery. I want to see what it
Okay.
does.
Okay, so we had this at 2.39. You want to put your phone, do the timer, and then we'll do a 2-minute, 3-minute charge. What do you want to charge it for?
Cameron, you are very good at your job. You are very good. Cameron, you get the job.
The job.
You got it.
Chipotle burrito eating job. Hired. I can drink water and eat burritos all day, sir.
You get the job, Cameron.
Nice.
Okay, I really appreciate that the questions you're asking.
Cool.
And I just want to make sure the stream is still working, because our last
Right.
stream did lose picture 1 hour with one hour remaining. Okay, I'm just putting my hand in here to see if we still have. Yep, and you can see that we're still here. Yeah. Okay, so we still have picture. Good. I am grateful that we still have sound on that last hour, but because what we were doing in that repairing your battery was very visual, I know people want to see that. Okay, Cameron, I do not know how or why this is working, but I'm very happy to witness this project with you.
Here, I'll turn my stopwatch on here. And
Yeah, would you?
we'll
Because
have
I'm
it
getting,
ready.
I have my message on do not disturb,
No,
but I'm
it's cool.
still getting messages.
We'll do it like this. I'll probably get some like really embarrassing text go
Oh,
by.
so you might
viewers,
too.
Viewers at home, just get ready to LOL when something passes by my phone.
Yeah, do you want to see Cameron's messages or Joseph's messages?
Yeah.
It's because we both have it on do not disturb, but we're both still getting messages.
Oh, I can't wait to see what blasts in my phone right now.
Oh, it's
All right,
something.
when you hit that, I hit start.
Okay, so here we go, and we have to watch temperature on this. Is my thoughts. We are not
Yes.
reading voltage right now because I don't want to burn the meter out. I don't know what's
Yes.
going to happen. Cameron, if you want me to stop the motor, just go like this with your hands. Go like that.
Okay.
Because if you panic, if something happens, because we don't know what's going to happen right now, and if you say a loud sound, I could lose coordination and have trouble turning this off.
This is the
Yeah, this
Stop.
one
signal.
means
Cool.
so we'll stop, okay?
Got it.
And that way I can just easily reach over and just stop it.
Sounds good.
Ready?
3.
So we're gonna leave it on this time.
We'll leave it on for 3 minutes. Is that what we're doing?
We could do that. Now these are gonna probably get super hot. I'm gonna leave it on
Yeah.
low.
Okay.
So that's 350 volts. That should not exceed our our 440 capacity.
Correct.
420 to 440 roughly. It's one of
Yes.
those. But if they burn out, then we just know there's another factor or variable that we are still learning about.
And if one burns out, I would sort of expect this isn't getting any power, but who knows?
That would be interesting to look at too.
Yeah.
So if you would, as a note, if it burns out, remind me to see
Test,
to still test that.
these leads
Yeah.
with the voltage meter if it burns out. We will do
I
that.
like that.
Cool. Okay.
Yeah. Okay. Shall
Want
we?
to do 3, 2, 1 and do it as though we're like nuclear technicians?
Sure. Absolutely.
On my mark.
On
3,
your mark.
2, 1.
I'm trying not to stare at them, but oh, it's beautiful.
I can't help but want to know what this is doing.
Me too. I want to know so much.
Okay, I'm going to use my
What
meter
if you
that's.
put a light bulb, or I don't know, whatever.
I'm going to use the meter that works sometimes right now. Let's just see if it's showing anything. Would you touch it on, Cameron?
Yeah.
Can you do both?
Yeah.
This meter may not work, but let's see.
Anything?
Yes, it's reading right now.
2.97. Oh, okay. So it's doing something. It's doing what? Yeah, it's just like 5. Okay, we were at 2.39, so we're at 6/10 higher or something.
Let me move this light.
Sure. And it's slowly climbing because it's slowly accepting some charge. These red lights seem to be pretty happy. They're
Don't-
not bouncing up and down. Like, see how the intensity increased and decreased?
Oh, it's getting close to something.
Consistent?
Something happened. I don't want it burning anything. Can you lean the battery?
Yeah.
It was touching that wire.
Okay.
I don't want this to melt stuff.
Yeah, gotcha. Oh yeah, you can feel they have heat.
Yeah,
They are warm. Okay, here's
because
back
red's
to
like
your-
infrared for cooking food and stuff.
Oh, yeah, okay.
I mean, that's just my thought.
Okay, I'm back to connected again.
This is up to 3 already.
Yeah?
It's putting a lot of power in, Cameron.
Yeah?
It's charged. It seems to be, well, like you said, it charges faster when it's low,
Uh-huh.
but it seems to be charging even faster because we got possibly because we have I'm going to call them our spark gaps in there.
Yes.
Is that okay with you?
Sure. Oh, okay, this is the kind of thing here. We could do our two condition observational research where we could do this condition for 5 minutes on 2 similar batteries. The first battery with no spark gap, the second battery with spark gap, and see the increase in total voltage over time. You know?
Oh,
In the same amount of
yeah.
time. And the change in conditions would just be spark gap or no spark gap device.
I like that.
I think, who knows, maybe for next experimental session, we've got to get our batteries, just like somehow figure out some consistent batteries to try with.
Look at this. It's going up steadily, it looks like.
Great.
This is still warm to the touch. It doesn't change. It's room temperature.
Yeah, I don't notice any heat there.
Cameron, you're not looking at the bulbs, are you?
I'm not staring at the bulb, no. Want to call it at 4 minutes and
I'm seeing voltage go up. I want to keep watching it.
okay, keep going. Oh yeah, I mean if we run
Look
it
at this.
for
Are you
10
seeing this?
If we run it for 10 minutes, maybe we could go up to 4 volts.
Yeah, you see what it's doing?
Okay, yeah, because we've had it running 4 minutes. It was at 2.3, and then it was bouncing around 2.9. I'm going to say it went up a couple of tenths. Maybe it's going up a tenth per 2 minutes. So if we need to go up to a full 10 tenths, it gets about a 20-minute charge, possibly.
Yeah.
Am I not touching it right? Is something doing wrong? Oh, there it is. Something's not working in the connection.
You got to
Okay.
push down on that one. Down. Because that's paper here. But the meter might have also stopped working. No, it's working there.
3.1 something. Okay.
You got a good connection again? You know what we can do? Let's go ahead and connect that with connectors.
Yeah, with clips.
Yeah, yeah.
that
Sorry about that, Cameron.
works.
Sorry about that. I was so excited. I forgot that you were home. I didn't really think about it.
That's fine.
Where's our clips here? Okay. Ready?
Yeah. Start looking. Okay, 3.15. I'm really impressed. Look how thin this aluminum is, right? Try to squeeze this structure. Let's see how rigid it is. Squeeze it.
It's very strong.
You can't squeeze it. I
Yeah.
mean, look how thin that is.
Yeah.
It's quite amazing how the aluminum got strong. Seven.
Okay, we can do another test if you want. It's going up pretty steadily though. And fast too. That's the fastest I think I've seen it charge. This one charge the battery.
It's definitely noticeably fast. That's good. So what do you want to take it off and try? Oh, look at this. We did 7 minutes, and we went up. We could take it off and see where it is, but it was at 2.39, right?
Yeah.
We could take this off and say, and wherever we end this, in 8 minutes, it's gone up from 2.39 to wherever it stands. You want to take off the spark gap device and give it another equivalent amount of time and see if it, I don't know if it would prove anything by,
If it increases more slowly at that point. Or
Is it prove or do you mean if we'll learn anything?
You got it. I'm not making proof. I didn't pass geometry. So no proofs for me, sir.
Look at that voltage going up. It's so nice.
So
Look
we
at that.
definitely went up 0.3 of a volt so far in 8 minutes.
Okay, well let's go ahead and let's see. The temperature's still cold. It's cold. I mean, it's cold to the touch.
Nice, yeah.
I turn that off.
Okay.
Just leave it on. Doesn't matter. That's funny. It says 80, but it feels cool touching it.
Yeah, I think this background in the room is 80. I think that's
Is that what it is?
Existing here, pretty much. Maybe.
Yeah, the table is 79.4. So yeah. We could even do the. Nine 79.7. This part.
Yeah. Okay.
Okay. Look at that. Okay. Let's try something new. All right. I can leave it on. I'm gonna stop this.
Okay.
Okay. Okay. You want to stop the timer?
Yep.
Wow, I'm really excited by this
Yeah.
experimenting.
What's the next step?
The sky is not the limit.
I know.
It's not. I thought it was. They said it was. Was that a fable?
It's all fable.
It was a fable.
Anything not in your hand is a fable.
Okay. Okay, Cameron. Here's a thought that crossed my mind. I want to know what you think. Yes.
What is this voltage right now? Now that that's not on.
Let's see.
No, the whole thing went up by okay. What's 2.39? What's 3.15 minus 2.39? We're gonna call it 7/10 or something, just roughly. We gained 7/10 of a volt in 8 to 9 minutes, right?
Mm-hmm. This is hot right here. The coils. I need to have a way to cool this, like a fan or something. That would be good because it gets hot there.
I wonder if you had one of these guys and hollowed it out and just had it in there.
Yeah, or even if there's a way to connect one on this side too,
Yeah.
or just yeah, because that would yeah, and then I could put
Maybe.
holes through here too, holes that let the air flow through. But also, meanwhile, maybe just getting a small fan that just blows air on there. Just picking up a small fan.
Portable fan.
Yeah,
Sure.
like a small computer fan or something, or just a small high-powered fan. Yeah, so that definitely went up in charge, and it seemed to do, just from observation, it seemed to do it better than without these. We'll call our spark gaps, which are neon bulbs, purchased on Amazon. Thank you, Amazon. I'm still waiting for the Amazon scooter and the Amazon car.
Oh, nice.
Wouldn't that be neat? It's just a thought that crossed my mind, like an Amazon electric car. Or...
Wouldn't surprise me if they had an Amazon car. Is there an Amazon phone?
I don't know, but the Amazon does have, I think, their own brand of some products, which are good. I've bought their... One example is this tape. This is Amazon. So I was looking for... what's it called? Gaffer tape? Which is what I like about it is it doesn't leave a residue and it's very sticky and it doesn't leave a residue, right? That's how I understand gaffer tape, which is made for, they call it gaffer tape because a gaffer is a position on a movie set, and they use, when they need tape, they have what's called gaffer tape, and it's really strong, and when you take it off, it doesn't leave a sticky residue. That's my experience with it and my understanding. I'm telling my own understanding of it. Well, Amazon, that tape can be expensive, and this is 3-inch tape. 3 inches, I guess we'd say width or depth. And yeah, it's working. It's
cloth tape, basically.
I don't know what the material is, but it works very well. It works very well, and I'm happy with it. And it cost. It was competitively priced, and maybe even cost a little bit less than some of the other, really big names. But they're all good. All the choices seem to be very good. I just wanted to try it out. So thank you, Amazon, for making products. So where's the electric car?
I know. Where is it?
It's probably being designed right now. Anyway, so where are we? So here's the thought that I had. And I want to know what you're thinking too. I was thinking, since there's 2 of these, right? There's 2, right? And they're each sending out, they're each pumping pressure. We can call it a resonant force, resonant flow, resonant pressure, resonant voltage. I don't know what to call it. These are some of the words that have been used. If you've studied Gerard Morin, you've heard some of these words. But I'm thinking, since we have one wire, and I'm not sure which one, we have one of these, it looks like it's this one, we could try putting the other wire, we could put 2 in series on the other wire and just see if it...
2 more neon bulbs?
Yeah,
Sure.
on the other wire, and then just see if what it does. Does it charge
curious.
slower? Does it charge faster? Does it not work at all?
Yeah.
It's just thought. Now, if you have any thoughts, I want to hear them too.
I like that. Let's do that. And my other thought was just to try the spark gap device between the rectifier and the battery. Whereas now the spark device is between the machine and the rectifier.
Okay.
But let's do yours first.
And if it vaporizes, dematerializes the battery, we learned something.
All data is good data.
All data is good data. Just have your eyes closed and be ready to run to the sink or the fire extinguisher. At any time. Okay, so what are we doing now? I'm soldering. I'm soldering.
More thingies?
Cameron, you're very good at your job. Okay. I have 2 right here. This is the package. I know I already showed this earlier, but I'm just showing it again. This is Amazon.
One curious thing for the future would be if we could get a hold of a capacitor that's somehow within the voltage range where we're working, and see, can we do this where instead of a battery, we've just got a capacitor? Can we charge the capacitor up and use that?
I like your thought, and I do have some capacitors. Now, when you say within the voltage we're working, what numbers come to mind? Are we talking about match
Under 500.
under 500?
Under 500 volt capacitor.
How would I know I have a couple? Let me just see what I have, because I know I have
Yeah.
some. And when you said this has probably taken a year of collecting getting the parts together, it really is kind of collecting here and there.
Mm-hmm.
But all the while studying, thinking about, oh, what is this one? Let's see if we can figure out what this is. This is one I had. Can you read this by any chance? And you can put the magnifier on it.
Let me grab it. I'll bring it back there once I find something.
And I'm gonna solder these neon bulbs
Okay,
together.
I got it. Yeah.
I'm gonna solder the neon bulbs together here.
110 VAC. We've got
Oh, 110 volts AC. That's it.
Yep.
That's what it is.
110 volts. So it says Whirlpool. Oh yeah, so this is a capacitor to start a. Okay, let me show the camera now.
And use the magnifier. Yeah.
So here we go. It says W2, which is probably the Whirlpool 2, just standard capacitor for when you're fixing a Whirlpool washer, dryer, whatever. And, oh my gosh, sorry folks at home, this is hard to see. It says 110 volts on there, but basically it's a Whirlpool capacitor to... Joseph, are you familiar with why capacitors are used in things like washing machines and stuff with big motors?
I've heard something called a. Let me see if I can get it to focus. Called a start capacitor for motors.
Yes. It's my understanding that
To get it to turn initially, it has to dump. It helps give it a boost
yes.
of charge, and get it spinning. They call it. It can be a start. I don't know if this is a start capacitor. I don't know that. I don't know what this is. I just know that when I see a capacitor, it becomes part of the collection because I don't know if it could be something I could use someday.
Mm-hmm.
And so while I'm studying and reading and experimenting, I continue collecting parts that may be of use. And one way to find out if it works is to try it, right?
Yep.
But this might be too low of a voltage.
It may just destroy it by hooking it up.
Well, that's okay. I mean, the thing about capacitors is if it's too much power, they can explode.
Great.
I did it before in a controller. Luckily, it had a metal cage around it, and the capacitor just popped inside. I think it blew the top off of it, and it's because I was running too much of a load on it, and which is too much amps, I guess, too much volts and amps probably. I'm having some trouble getting these two to stick together. Would you help me?
Yeah.
By,
pliers or hold it with the screwdriver?
That's a good idea. Maybe we can...
Well, when I helped my friend work on air conditioning, one of the things that we came across a lot was a burned out capacitor on an air conditioning. Oh my gosh, I can't remember the compressor. The compressor.
Can you back that up a little bit? Right there.
Okay.
I somehow broke this recently. I don't know how. Or maybe I don't need that. Let's see. That works.
Okay.
I don't need that.
Here, let me get. I gotta get it under there again.
Wow. We're just soldering. We'll be right back.
How about there?
Yeah, that's good. You got it?
Yeah. Okay, I saw a lot of burned out capacitors up on the roof on air conditioning compressors. And, you replace the capacitor and then everything's happy again. It could mean that your motor is fried and then you need to replace the motor, but we probably replaced 10 capacitors and like one motor.
Oh, so mostly the capacitors went out. Oh, it didn't hold. Let's try it with, maybe we could try it this way. Let's try it this way. Let's try it with needle nose. we always have some. There we go. So we're just trying to solder. Sorry for the delay, everyone. We're just trying to solder these two neon bulbs in series, and we're going to have neon bulbs in series on both wires, on both outputs of this, both sides. Right now we have one side, so we're going to work on that right now, and Cameron and I are collaborating and working together on how to do that. And see, you can see the solder there, but it's not sticking to the other side yet. We'll get this though. And as a last case scenario, oops, I just put our tool on. I'm thinking, Cameron, that I could just put some wire in there between the two, and then they both will stick to the wire.
Will it twist if you just manually twist it a bit? That can kind of mechanically get them
That's a good idea.
close, and then once they're mechanically twisted, you can.
You're right. Let me do that. Let me get this off. That's a very good idea. Thank you.
Uh-huh.
And that's the collaboration part.
Two heads are twice as heavy as one.
Okay, so Cameron suggested just twisting these together and then we can solder it, because I was having trouble getting them to stick. So we're just gonna. This is our series connection. I do have the proper. What did you call those plugs? Those I mean the things I ordered. What did you call those?
Which thing? The thing
That these are going to go into. The rail.
Oh, the what is it? Something connection block?
Yeah, we ordered. I ordered that.
Connection block.
But that comes tomorrow. So meanwhile, we're just going to solder these together. But this is how we're going to do this. Thank you, Cameron.
Mm-hmm.
And then we're going to solder, put some solder there. So, okay, so let's do that. So this time what I'll do is I'll just put this on top of here.
Mm-hmm. Mm-hmm.
And I could let people see what I'm doing, because people want to see what's happening. Cameron, would
Soldering's
you?
fun. You want to hold this and use solder on it?
Sure. Yeah, we could do it that way. So we're letting you guys see what we're doing here. Just putting a little solder to help make this a better connection, right? Oh, I need my zoom goggles here so I can see close. Magnifying goggles. Yeah, I did it. I got it on there.
Cool.
All right, so let's see what we have. Everyone wants to see. Yes, here it is. Let's see. Okay, let's see what this looks like now. Yeah, there it is. That's the part we just soldered. So that's called series. It just means that we're connecting two wires together. And because it's AC, it's not positive and negative. It's just just connecting it. I think these just want to see a pulse. They just want to see a certain voltage and maybe a certain
Oh yeah,
frequency.
the positive side versus the negative side. I almost don't see much of a difference between that. But I'm gonna bet it'll work on each side, or neither will work. I bet 0 work or 4 work is how I'm predicting.
Oh, having the way we're doing this?
Yeah.
Okay, so let's now add. Where's our other side? This is our other side. It goes to here. So I'm going to unplug here. I'll unplug here. Okay, I'll unplug here. Oh, you know what? Let me change the light, because I had a problem with the light. When I run it too low, the battery was having trouble recharging. Oh, it's still full.
Okay.
I'll change it anyway. It's at
This is that. What brand is that thing?
the Milwaukee.
Milwaukee.
It's at 3 of 4 bars. Let me plug this in here. 3 of 4. Yeah, the cells, I don't know if they're going out of balance or what's happening.
I have had one of my. Oh no, this is the dead one I gave you a while back.
Oh, okay.
My fake Makita battery packs died, but the original ones, all of them are still good.
Oh, okay. That's good. Okay, so let's, all right, let's see. So we're in the middle of connecting this. So we're going to connect, let me get one more white wire.
So awesome having test leads.
Oh, yeah.
This is like a fantasy studio here, for sure.
All right, so I'm going to connect this to, how am I doing this? This one's going to go to here.
Something goes to this.
So this is going to go to here now. And then on this side, we want these to go together. So that way both sides have light, the neon lights on them.
Mm-hmm.
I don't know what this is going to do, if anything.
And we're gonna sit that somewhere safely. I figure hang it off of there will work.
I don't know. Let me just see what it does.
Okay.
I just don't want the bulbs touching anything because they get
Yeah,
hot.
Yeah.
So we kind of have to watch that.
I'll watch for those. These ones are safe.
It also has
You
to
think
not
that's
touch
gonna
any
sit?
leads. We have to kind of peek at it once in
Yeah.
a while, because it might drift. Okay.
I'll keep my eyes on it. I think it looks, sciencey safe enough.
This is very interesting, isn't it, Cameron?
What's your prediction right now that's gonna happen?
My prediction is I'm going to learn something.
Right on.
That's the only thing I know.
Mm-hmm. My prediction is we're gonna charge a battery one day, or today.
I like that. Cameron, do you want any juice or any water or anything?
I'll pass. I'll top up after we do
Okay.
the video.
I think this project is filling your battery up.
Mm-hmm. Mm-hmm.
And I mean your human battery.
The brain battery, or the homeostasis. You know what? I talk about homeostasis in life, but this is like homeostasis is just getting back to a natural state, and everything. You've got all your bottles of sodium and sugar and water all filled, but this is like more than homeostasis. This is getting new input.
That's
Gotta
really
come up with a
awesome.
different word.
And when you said you were really young when you were thinking about projects like this,
Mhm.
if I say it that way, you were telling me a story about, I forgot how young you said you were, but you were really little, and you're just a kid, and you were thinking about like how you could, what were you thinking about? How did you explain it? With the generator or something?
My dad had gone to an electronics class, and he was interested in all that stuff. Always worked on cars, worked with wood, just, was a fix-it guy. Although he was a professional, worked in an office and whatever, but
Mm-hmm.
for hobby time, he welded, did electronics, and so I was exposed to it when I was as young as I remember, so like 5 or before. I mean, my dad would show me anything adult would do when I was at the youngest of ages. And so I had batteries and wires and motors and light bulbs and would stick them together at, maybe the age of 5 or so and just play with them. And I remember taking this thing called a Stomper, which was a little 4-wheel drive truck you'd get for like $5-10 at Toys R Us. And it used a little 1.5 volt motor and it had a gear driving the back axle. And I remember taking that and thinking, I want this to be faster.
Mm.
And I didn't take 2 batteries and put them in, series?
Yeah.
I didn't put 2 series batteries, but what I actually did was I took that gear from the motor and somehow flipped it over or something, and I re-geared it to go faster.
Wow.
And so when I did that, I just thought, wow, everything is possible.
Yep.
And I also had seen that there were generators on bicycles.
That was a natural experiment.
That was a natural experiment. The generator could power a light on the front of the bicycle. And I asked my friends asked my one friend, can we just, since a generator is a motor and a motor is a generator, why don't we just put power into that and use it? And he said, wah, wah, you can't do that. And
Fables.
Yeah,
fables.
And it's true. It was a little motor, not capable of a lot of horsepower. It powered a little bulb that was barely anything. But since then, since I was the youngest, I always wanted to power something with almost nothing.
And Cameron...
And that's what we're doing. This is where we are.
Well, and what you're saying when you say nothing, you mean, what you actually mean is without putting your own input into it. It's because, for example, when you read about the Big Bang, I mean, it's called many things, the Big Expansion, the Big Bang.
Mm-hmm.
Energy, how do I say this? Maybe this is one way of saying it. I'm just paraphrasing, and this is my own way of understanding it, and I could be completely saying it wrong, but I'm going to try my best. All the matter in the universe, this is one theory, right? The Big Bang Theory. The way that I process the understanding of that is that they're saying, so all matter, all mass is pure energy. It's made up of charge. Particles are all charges. So if you squeeze all the mass, all the matter in the universe into the space the size of an atom, that's what the universe theorized.
That was right when the Big Bang
That's
was
what
going to happen.
the big expansion was, that all of that energy coming from that size, that area, the space that is an atom, right? How amazing is that? So that's how much energy.
So we're just living in the blast of an M80. You and
Well,
I
that's a
are
theory. It's a
living in the
theory.
blast of an kind of.
Well, that's
a
one way.
5 billion year old M80 kind of.
Yeah, but that's also not, and I don't, maybe this is the wrong way to say it, but that's also not acknowledging that all of the matter that we are and see, the particles are still being charged constantly. So even if that happened, everything's still being maintained. Like when we talked about renormalization, it's like, we're not going to look at what's maintaining everything.
So we're not in the middle of a curve where we're up at the peak of the curve, and then we're going to go down into a fizzling out thing.
No.
You think we're in a constant generation where, I don't know, when I talk about a curve, maybe it's wrong. We're on sort of a steady graph, or on a climbing graph where there's more energy, or I guess I don't even know how to talk
Well, I
about
think, yeah, I think there's a lot of layers of ways of understanding the different parts of what it's the way it's theorized. I mean, I don't know how the different ways come together and what, you know what I mean? I don't, but I'm just saying, like, these people that studied this their whole lives, and they're really good at what they understand. They understand how much energy can be in the space that is an atom.
Okay. Yeah.
That's just the specific. It's when I look at that, I'm not saying I agree or disagree with their theories. I just think it's interesting that energy can have that much density, right? Or they wouldn't have come up with that theory. It's like they know, you know,
Sure.
that's their line of thought, I guess, along with many more lines of thought. But so where were we on this?
I think we're going to flip that switch. Is it all wired up, and we're going to flip it on and see if 0 lights on, if 4 lights are on, or everything.
And see what the
low?
voltage does? Should I have the meter disconnected this time? Let's see what it does. I hope it doesn't burn it out.
Meter's
So
on?
we're still above what we were. Remember?
Okay.
We're still.
We're at 3.1.
If you want to, you can start the.
Oh yeah, I'll start the
The
timer,
timer.
and we'll see what goes on.
And I was checking to see if the stream looks like it's still working,
Okay.
and it does look like after the commercial, it does look like the stream is still live. Let's see. I've got it in my hand here.
I just put the phone there, and so the phone's there, and so yeah.
Yeah, it's okay.
It's on?
We still have visual, and apologies for the loss of visual on the last stream, and I still don't know why that happened, but that's okay, because we still have sound on that video, and we're here again making this video.
So you ready to flip on?
Yeah. So what we did. Do you want to say what we did, Cameron?
We added a second series 220 volt spark gap to the opposite, the other wire going to the the other wire going from our machine to the rectifier. So now both wires going from our machine to the rectifier have a dual 220 volt neon bulb in series, such that we're hoping that doesn't burn out, given we're capable of 300 to 400 volts right now.
Yes, and Cameron, I forgot the reason I brought up the big expansion theory, the Big Bang theory. You said something about when you said, can this small little generator power this motor on your bike, right? Is that what it was, a bike?
Yeah.
And my what I think of when I hear you say that is, the answer is not, can it power it? I mean, you can ask that. It's a good question. But my mind goes to, how do we use this generator to power the motor? Because you might have to change it the way you change that gear to make it go faster. You just flip the gear over. That's what I understand to be the solution to what you asked.
Sure.
The generator, as it is made to power probably a LED light, or not LED light, but like a light bulb. if you change something in there, and the question is how do you change it, and what are the magnets doing? What is the copper coils doing? What kind of coils are you using? What direction are the magnets passing those coils? And do you have iron in there, right? Do you have iron in there that the coils are wrapped around or not? And it's what are they doing, and then how does that keep your battery charged, or how does that power your motor, you know, if you want to look at it that way. So, and it sounds like your friend was coming from the point of view of almost like the renormalization thing, where it's like we're not looking at the energy that maintains everything. You know?
We're just looking at what we add, which is equivalent of a 1.5 volt AA battery, which is not enough to move your human being on a bike.
Right. It's a thought. I'm just telling you where my mind goes. I mean, I don't know. I don't have anything but questions and experiments to try to learn from. So that's what I'm trying to do. Okay.
Cool.
So here we go. Shall we?
I'll do it.
Okay. And did you want to flip the switch?
You go ahead. I'm going to do the stopwatch.
Okay.
3, 2, 1, blast off.
Wow.
Dim. Oh, we've got dim, and we've got. I don't even see it over here.
Okay, let's do something. Let's stop the timer. I want to see what's happening. So these are a little red?
These are dim. These I didn't see.
Okay, you can stop that. I'm going to try turning it on higher power too and see if
Oh yeah.
Ready?
Yeah, do it. You want me to start it or
No, because right now I just want to see what this
Okay.
does. Yeah. And I also want to I didn't look at the voltage. Can you tell
I
me
did
what
not
that's doing?
either, yeah.
Okay, ready?
Voltage is the same. These get a little brighter. These don't. Voltage stays just the same. Voltage same.
Okay, and we saw with one, it was definitely charging, like the numbers were moving pretty good, right? Steadily.
They were.
Okay, so let's do this. Let's do that. Let's try this.
Do you want to take this one out entirely?
Yeah. Well, I don't know if it matters.
This one was getting more. This was illuminating more. I tend to wonder. Instinct
right now, I'm
is to
wondering if these are.
remove this.
I'm wondering if these are burned out right now. Let me just see that. Let me just see if those are
okay.
still working. Because last time I did this, when I was doing it myself, and I turned them off, they didn't turn on again.
Okay.
So let me just see if.
Okay.
Let me just see if those are even still working. Ready?
I predict they're gonna run. Whoa, Joseph. Interesting.
And what is the voltage changing? Okay, so those are. I'm guessing those are burned out, but let's see if the voltage.
Voltage has made no change from 3.136 during the last minute.
And it usually changes, right?
It usually does.
Okay, this is what I'm going to do because I don't want to burn these out.
Yeah.
That's making me think. Let me add one more.
Okay.
Because those burned out. This is
Okay, yeah,
when they
yeah.
burn out. When they seem to burn out, if that's what's happening, it's when I turn it off and for some reason they won't turn on again. That's what the one did last night. That's how that one went out.
Okay.
Is this a one too? That's a new one. We don't know what
that was sitting over here. I was just clearing the area
Okay.
before.
I'm not going to risk it. I'll just get a new one.
Okay.
And these hopefully still work. We didn't get them too hot. So I'm going to solder this. And I'll do it
Uh-huh.
the same way we did already. Do it the same way. I'll just do it the same way. I'll wrap them together and then solder it. Darn, so the bulb burned out. So we still have to do, maybe what we can do is if this works, if this turns on, then what I'll do is I'll bypass those. I know those are out. I mean, that's a different test if we want to see if burned out ones can do anything for us.
Yeah.
But I don't know, when it's burned out, I don't know what's the difference between it's burned out and not burned out, right? Like this.
Or I still don't really comprehend why it would have burned out, or when it burned out. It burned out during. It seemed like it was working until we added the other ones.
Oh, so
I mean, I thought it was.
You think that's what burned it out? Or it got hotter then or something? Because we
I
did
don't
turn
know
it off.
hypothesis as to why, but I didn't think that I noticed anything that made me think that the first set burned out
I just thought it was working and we just turned it off.
Okay, how about this? I'll leave that in,
Uh-huh.
and we'll do these in 3 and just see if anything happens. And then we can disconnect the other one and bypass the other one and see if that changes anything.
Because I want to see a change in the voltmeter, because there was change before.
Yeah.
I feel like...
Okay, you let me know what you see, okay?
Yeah.
Ready?
Yeah. I don't think that it's going down, up. I don't think that it's doing anything for the volts.
Like it was before, right?
Yeah, I tend to think it's not connected anymore.
Okay, so should we bypass this
Yeah.
and see if it
Why not?
if it does anything? Now be careful over here because this is
so it
close to
doesn't touch
things.
anything
Yeah.
fine. I've got my eye on it.
Okay, are we going? Ready?
Ready. Okay. So that's doing stuff, and then this is changing. So look, with those in, those are dead, or one of those is dead, right?
Mm-hmm.
Maybe both are dead, but maybe one's dead,
Mhm.
and that's affecting. This is making that work. So.
Okay, so now I'm gonna make, because we want our experiment, we want to still test our experiment with 2.
Okay.
I mean, yeah, with 1 on each line. So now I'm gonna connect another set, another 3, and
Okay.
for the other side.
Okay.
And I'm hoping 3 is going to. I mean, we could do a lot more. We could just do a bunch. We could do, But let's try 3.
Okay.
What do you think? Should we do a bunch?
Yeah.
Like, see how many we could do? Should we see how many we could do? Should we see if we could do, like, just
I like the 3 idea.
for now?
Yeah. I like starting small.
Now, if 3 burns out, then I can jump to, like, all of them.
Okay.
Like, just light them all up,
I guess.
Oh, and I didn't tell you that earlier. I didn't share that with you. I didn't think I forgot to share with you that. So remember how we were talking about how when you send power, the kind of power that's in our walls in the house, in the home, that
Mhm.
power, not the power that's before the transformer, the pole transformer on the pole,
Mhm.
but after it. So between the pole transformer and the house,
Mhm.
that power, when you want to power a tool or something that takes a lot of, if we just say a lot of watts, I guess we
Mhm.
could say, that cord will get hot and
Mhm.
it has to really struggle, right? Now with this kind of system, my understanding is you don't lose over distance. And
Okay.
this is a similar energy, if we say it that way, to the energy that's in the power lines.
Hmm.
See how the power lines are really far,
Yeah.
but you're not losing, you're not heating up, right? They're not heating up the way our extension cord does.
Yeah.
So it's a different kind of energy. So the question is, how do we use it? That's the question I'm asking,
Mhm.
is how can I use this to charge my batteries,
Mhm.
right? Interesting?
Yes.
Okay.
I'm gonna crank that AC.
Go for it.
I should probably go in a couple minutes, but
Okay.
crank this one turn or two turns over on the switch.
You could do 2. 2's the highest one.
All right.
Yeah, you got me thinking, Cameron. So the Big Bang and the big expansion and all that. In a way, those seem like there could be fables too. Are those fables too?
Oh, it seems pretty fable-like.
Because we don't know. We weren't
Yeah,
there.
not-
And
The
this
science
is
dudes really think they know, but
this is 14 billion years ago.
it's a lot of confidence to say you know what happened a long time ago when you weren't there, and I've never felt that confident in those sort of stories.
Yeah. Okay.
Yeah, it seems like a fable. It seems fable-ish.
Okay. Let's see what this does. So now we have 3
Yeah.
and 3. So that's 2, 4, 6. So this should be able to withstand around 600 volts or more
Okay.
on each side.
Okay.
So if they
you
burn
can crank
out-
it all the way, maybe, if
Yeah.
you wanted, or
Let's see what it
we'll
does.
see if it goes at all.
Okay.
I kind of tend to predict these are just not going to work and these are going to glow a little bit. That's just my prediction this moment.
Okay, let's see how this goes.
Oh. Oh, look, this one's burning out right now. Turn it down. I would think. I mean, maybe I'm wrong, but...
What's the power doing, Cameron?
It's raised a little bit.
Is it
It was
charging?
at like 3.16, now it's at 3.19 maybe.
Is it charging fast? Oh, what's? Oh, I just burned the cord. I just bumped the cord on
Ooh,
there.
I see. Okay.
Is it charging faster than before though? That's one question.
I see what you're talking over here. Let me go like
Thank
that.
you, thank you.
I didn't do a method to figure out the climb versus the time, so I cannot answer that.
Well, it's a rhetorical question to just think about too. We don't have to answer it.
Well, every second or two it's going 1,000, so...
These are things we could time though too.
Yeah.
But it's interesting that it's working, right?
This middle bulb, I really feel like it's turning to a white light. I feel like this one's going to burn. I feel like this side's going to stop in like 30 seconds. But we'll see.
Okay, I'm gonna go full power and just see what it does, okay?
Yeah, yeah. Oh, look, that light already stopped entirely.
Oh, but the other two are still
The other
working.
are on.
Oh,
This one's getting a little brighter. I know I'm not supposed to look at them.
Yeah. And let's see if that affects this.
Okay.
It's interesting that one of the bulbs went out, but the other two are still working. Power's going through there.
Hey, whoa.
Did I do something?
It just sizzled a bit, but I just pulled it off. So
Thank you.
We're good.
I smell it.
Yeah.
Sorry.
All good.
So I'm wondering if that bulb being out, is it how it affects the charge, if it's charging faster now. I wonder.
Do not know.
And Cameron, look. Somehow the energy's still going through this even though there's no connection there and there's no...
Unless the materials inside it are melted and fused, creating connection, right?
Well,
Or who knows, maybe it just sucks it across the gap, you know?
the way a transformer does?
Yeah, you know what? It probably doesn't have to have physical connection because energy can travel without a physical connection, as we know through many.
But I have a feeling once I turn this off and turn it back on, I don't think any of those will light. But maybe.
From your experience, that's what's happened?
No, I'm wondering that. I wonder. I don't know.
The voltage is at 3.24. Yeah, so it's increasing steadily. Okay.
What?
So next time we need to figure out our amount of rise of voltage, okay? Two conditions. So that we can tell if the spark gap device is significantly affecting it.
Okay.
But then also we still have our other conditions of spark gap between the rectifier and the battery. You know, that could be tried.
Yep.
So yeah, so these observational things we're doing, we could keep doing some more.
Let's see what the Hertz is reading on this. Oh, I can't read Hertz.
Okay.
3.256. 7. 8. That's a pretty quick increase to go that fast. And it's not getting hot? Room temperature.
Okay. My finger down here feels hot, but it's the bulb.
Yeah. And notice, we're powering those bulbs and we're still charging the battery. And this thing's not slowing down.
Yeah. How's the heat of these things? Are these like 130 or something?
Yeah.
Okay.
This one's going to be hot. It doesn't have any fan on it.
Okay.
I need to put something on there. If you think of something, let me know. I don't know what to put on it.
If this shaft doesn't wiggle too much, like I said, sitting something like that in between there maybe.
I want to put a fan
Or yeah,
just
put it
up
on the
to
back.
this. Yeah, just.
Sure.
But I want a high-powered fan, like a small one with high power. And I've been, I don't know. I've seen some computer fans. Then how do I power the computer fan? You see the charge?
Yeah.
7.3,
Okay.
4, 5, almost 5, 5, 6. So when we didn't have the bulbs, it didn't charge that fast, did it?
I think we need next time, let's get a little notepad or something.
Okay.
A little like lab book. And little numbers like we're dealing with to compare before and after, I think we gotta write them down. And also, just choose how much time we're gonna run it for, and say we're running this for 60 seconds or 90 seconds or however long, and say this much rise in this many seconds, so we can compare it before and after. Let's just add that to the next round.
Okay, what do you think? It's going up steadily.
Going up steadily, my hand's getting warm, but not too warm.
Okay. What do you want to do? You want to do a different test, or?
Turn it off. I should probably go.
Okay.
I got things I could do, but I think we kind of know if you want to just start again next time and do spark gap on the other side of it, we could do that.
Yeah. Let me speed it up and see if it does anything, okay?
Yeah. Climbing good.
Yeah. That's good. And now let me just see. I just want to see if it'll turn back on.
Yeah, cool.
Should we see?
Yeah.
Yeah, they did.
Okay.
It's amazing. Oh, that one looks like it's going to turn out.
Look at that. Yeah, you know what? You're right. There's something about turning it off
Yeah.
that I don't know what it is about it.
Oh, this one just went out, I think. Oh, they all went out.
I wonder what did it.
They're out. They went out. Okay, let's see if the voltage changes. Nope,
No, it's not receiving anymore.
it's not charging anymore.
Yeah.
Okay, I'm just curious, as a last test, I just want to see what it looks like to compare it real quick,
Yeah.
without any bulbs, bypassing
Sure.
all the bulbs. Cameron, would you take this one?
Oh yeah.
Just take it by the wire. Does that burn you?
No. It's a
Okay.
little warm, but it's fine.
All right. Okay, I'm just going to see now with no bulbs. We just want to see if it looks like it climbs the way it did when the bulbs were working.
Yeah.
Ready?
Yeah.
Okay.
Okay, and it's a 3.243. Yeah, it's climbing. It's like it jumps up a lot, and I bet it's going to sort of plateau, like not quite increase as fast, but it seems to be increasing pretty good.
Wow.
Right? It's
Yeah.
climbing by the thousands really pretty
It is.
appreciably.
Yeah.
But also, we haven't tried spark gap between rectifier and battery.
That's
so,
right,
you
that's
know,
right.
We could. I'm gonna put that in our notes for
Okay.
next time because it'd be good to just jump right back into that.
Yep.
Actually.
All right. Well, we did some good testing today.
Yeah.
Okay, so let me close the stream. Thank you for watching, and we'll see you next time.
See you later, people.
And make lots of videos sharing your thoughts, your experiments, and your questions. And you can turn off comments if you don't want to, you know, use the comments. And let me think, you can turn off the visibility of the votes, like someone voting up or down. That way just you see them, and everyone else doesn't have to see your votes. And thank all of you for liking this video. Thank you. And if you didn't like it, I still appreciate that. I do. I had a teacher that said I'm trying to think of how he said it. He said the works that no one likes. He said, then you know you have something. When no one likes it, you really know you have something. And I actually had that direct experience where the whole class didn't like what I did, what I made.
But it worked.
It worked, and he liked it.
There's a group called Crisscross who did a song called "It's All Right," and they said, if you're talking smack, then I know you're on my mind, then it's all right.
That's
what they
very
said.
interesting.
These kids wore their clothes backwards.
Oh my gosh.
People talk
Okay.
smack.
Thank you all for watching the video and for being interested in learning with us. Have a great day and evening. Bye-bye.